Welcome, everyone. Thank you, everyone, for coming out and joining us for Austin Community College's first ever hackathon, RiverHacks. We'd like to thank everyone that played a part in setting this up, all you guys that came here and participated and made this a thing. Without you guys, we wouldn't really have a hackathon. We'd just be organizers. And we'd also like to thank all our sponsors, even members from here who pitched in last minute to help us out. And specifically, a big donor. We'd like to thank our donor from Centex, Mr. Supani. He helped us out last minute with a massive donation right on the spot, and a lot of the food. Thank you, Mr. Supani. And a lot of the food that you guys see out here, a lot of the stuff is made possible through these like big donations from Mr. Supani in specific. So thank you to him. Should we make like a noise test? So everyone make some noise for Mr. Supani. All right, so some quick introductions. This RiverHacks hackathon was presented by the Computer Science Club. We had a lot of the officers come in and organize this. So thank you to all the officers. And we've been planning this for a couple of weeks. So I'm the Vice President, Malik, and this is Nathan.
Hello, I'm Nathan. You must have seen me around.
Yeah.
President of the club.
Yeah, he's the president. And then we have over here
Patrick. So I'm just a member, but yeah, we've
one
all
of the
done
lead
a good
organizers.
job. Lead organizer, sure.
Yeah.
And helping out. Yeah, just like the rest, everyone wearing the Student Life shirt will be around if you need any help throughout the hackathon. So
yeah, we'd also like to thank Kareem for helping us out, set this up. Also Josh for helping us get a lot of the stuff set up here as well. All these are lead organizers. He's actually going to be the one leading the Smash tournament, so be sure to talk to him to get the brackets set up. Also, Alex helping us set up and everything, and Aaliyah, our creative design lead. And Jacob, he's been helping a lot as well. Yeah. He's gonna be our food guy, so make sure to stay on his good side so you get good food and stay fueled up. And we have snacks and everything outside. Just to reiterate, for anyone new that came in, please do not bring any food into this presentation hall. We have been fighting with ACC to get a reservation for a couple of months now, and they've been so gracious and kind to allow us to reserve this presentation hall. And we really don't want to get kicked out, and we really just want to respect the rules. Some other big rule is no more than 50 people in here. I don't think that's gonna be a big problem, since right now we're, I think, at about like 40 people. But in case some more people do come in, just be mindful of any restrictions. If there's anyone like telling you not to go in at a specific time, it's not because like we want to exclude you or anything. It's just because we want to like safeguard those rules and not get kicked out or step on ACC's toes with that. So.
Yes, hello everyone. So I just wanted to confirm something very quickly. If there is a need for any team to confirm reports, any situation, if you need any assistance or support, there is on the RiverHacks Discord server a channel called Assistance. So please simply give us a shout and someone will be able to promptly contact you privately. Thank you very much.
So as you know, we've been sharing a lot of our links, our cheat sheet. If you need any of that, it's all available in the Discord. And we also have a QR code that will be present throughout the presentation. So if you want to take a picture of that, scan it, and it'll have access to the schedule and any notes or changes that'll happen, as well as entering into some of the stuff we'll discuss later. This is the cheat sheet. So as you've seen before, pretty much our schedule will be in there, as well as the check-ins. So make sure you save that and reference that, as it will be showing the schedule throughout the hackathon.
Yeah, most of the stuff is going to be happening in here. So this is kind of like the central event place where most of the workshops and where a lot of the guest speakers are going to be. So just make sure to check back in here every once in a while in case if you go out into the hall. So real quick, some quick rules. Rule number 1, have fun. Semester just ended. We're not trying to stress you guys out with this. It's supposed to be a fun sort of event. No toxic competitiveness or anything like that. Another rule, only 50 people allowed in the presentation hall. That's not going to be much of a problem right now since we're not at that threshold yet. Also, no food or drinks, only closed lids in the presentation hall. If you guys see on your tables, there's like power outlets. So we don't want anything to like spill into the power outlets. That's very dangerous and can be a fire hazard. And please be mindful of others when grabbing snacks. We have quite a bit of snacks, but that's supposed to last us 2 days. So don't just go in and like stock up your pantry from our food table. So take one at a time. There's more than enough to go around. Also, another big rule is that all projects must be started within the hacking period. I.e., like if you guys start coding before that, you can use like a template. We'll provide you guys some templates beforehand. But if we see that like a big portion of your project has been started after 12, then it could pose a problem and could potentially put your project at risk for not being considered for a prize. So we'll look at like the timestamps for the Git commits and stuff. And additionally, notify any of the officers here. We're all wearing maroon colored shirts of anyone violating rules or any sort of misconduct. We'd really appreciate it if you guys like follow all the rules. This is our first hackathon and we'd like to have so many more hackathons. So we're really on edge here and we really need to make sure this goes smoothly and that you guys all cooperate with the rules that we have here. Additionally, there will be no harassment or bullying or any sort of like misconduct of any kind here. So if you guys see anyone or if you encounter any sort of harassment or anything like that here, then please notify us. That will not be tolerated here at all. We want to make sure that this is like an inclusive environment for everyone to have fun and share their passion for technology.
Very well put there. Also, I want to reach back to the sponsors real quick because that money also got us some really good gifts and prizes that will be given out. So it's just nice to have get that extra money to help get that going. We're gonna jump into what is a hackathon. So for me, this is my first hackathon, and I think probably some of you out there might be your first. How many have been to a hackathon before? Yeah, so a couple. So we might lean on y'all a little bit for some help with, helping people out as far as throughout the hackathon events. And we'll also have some mentors and stuff we'll describe here coming up that will be around, as well as the CSC staff to help facilitate that. A hackathon is a great learning experience and a unique opportunity to build a powerful network and grow your tech skills, as we're all here to advance and learn new stuff that we might not have known about before. It'll be a timed event in which participants join teams and collaborate on building a project. The aim is to design, build, and present the most innovative solution to a problem, and then pitch a final concept, prototype, or idea. You'll be competing in groups of 4 to come up with different project ideas. And we'll move on to the theme that you'll be working with for the next 24 hours. And that theme is...
So since we're a community college, a big theme that we want to see in projects is increasing access to education. This is open for interpretation, so you can interpret that how you will. Your project can increase access in any way, in any way. So it's pretty open-ended. So you'll have an opportunity to frame your project in accordance with this theme and not be restricted to one single type of project. So you can make anything, any sort of industry, as long as it's like technology related. And it doesn't have to be something that just like assists like a specific group of people or those with a special need. It could just be a way to view education, to help students like you and me to learn more efficiently. So it's pretty open-ended, and we definitely don't want to put you in a box, so we won't mention any like specific examples or anything to not like make you guys to not like ruin creativity. So it's up to you guys how you want to tackle this theme, and definitely do spend time brainstorming. Don't just jump in and start coding. Again, this is a hackathon, and it's about providing a creative solution. It's not just about getting some piece of technology out. So there will be some emphasis on like presentation, impact, and we'll go through the specific judging schema in a quick second. But do keep in mind that it's more than just like coding something up. So yeah, go ahead.
Yeah, just like he said, the judging, we'll jump into that next. There's going to be 5 criteria that you're going to be judged on. We'll kind of jump to each section as we get to it. We also have some judges that have also volunteered their time as well. So we'd like to thank them for helping out with that part of the process. Your projects are going to be judged on the following criteria, which is going to start with adherence to theme. So sticking to the overall theme, which is access to education, how this project relates to it, how closely does it connect with the prompt. The next one is going to be originality. So coming up with a very unique idea that hasn't been seen. How creative it is. Does it include features, other aspects that we haven't seen before? And what does it do differently than what's out there currently on the market or in different programs? Usefulness and impact. Is this project solving a problem? Is there an issue that this project is filling currently? The next one will be design and polish. So how does it look? Is it well created? The interface systems flow and work well. And one big thing about it is we're not expecting you to be the next big Google project, because this is all brand new stuff, and maybe we might have a really good project or more than one that we could work on and all become billionaires. So that's the goal. So no pressure, but just give me a fair cut of that.
One thing we forgot to go over technical difficulty, but this is how technically complicated is your project and how well is it executed. So obviously there's no there's no obligation to have like a completely polished or finished up project. But again, if you have like an intricate system design where you have like a whole like, I'm not going to say like the specific examples, but you know what I mean? Like if there's clearly more effort and more systems design emphasis on your project where you built out a whole overall product versus just like some small component, there will be some points given to like the overall technical difficulty. But also don't stress too much about having like a completely finished working product. Again, it's like 24 hours. So if you have a prototype along with a well thought out overall layout for your well thought out like framework or well thought out like plan for your product, then that's pretty good, and we'll evaluate it based on the idea and things along that line and like the impact of it.
We'll move on to the day 1 schedule. So this schedule is available on the QR code as well as on the RiverHacks site, subject to change, of course, as we've already made some changes throughout it. So as you can see, we're in the opening ceremony right now. Hacking will start, and then we'll get some food in here, and then pretty much we'll be doing a lot of our presentations from a lot of also the speakers. There's really a lot of people that put a lot of effort into this, speakers, donors, judges, staff, and then y'all being here as well. We do appreciate everyone that's played a part. So pretty much the presentations, we'll have dinner later this evening, and then also some games and different stuff going on. So make sure you're staying up to date with that schedule, and we'll have a good time.
Yeah, and another thing to mention is that for each of the items on our schedule, you'll be able to earn points that go towards a raffle to win some of those prizes right there. So basically for each event, including this event right now, there'll be a form that you can fill out, and if there's a specific password, and for this one it happens to be taco, all capital letters, and since that's what we're having for lunch, and yeah, all the links you can find for that form will be on the cheat sheet. So yeah, basically just fill out that form and you'll be entered into the raffle, and you can enter as many times as you attend a workshop. So yeah, the more workshops you attend, the better chance you have.
So snacks and drinks are going to be available outside the presentation hall, kind of where that screen is, behind this wall right here. No food or snacks in here again. Restrooms are located, the closest one is out the presentation hall, and then if you go left and kind of like straight forward over there, so left and then forward, it's in that area over there. Additionally, you can kind of wander around over there if these bathrooms are closed or something. So the second day, teams aren't going to be able to enter the presentation hall. I think it's on Saturday. Tomorrow is going to be rented out for another student life event. So instead, we're going to be meeting outside room 1230. And we'll send out a map on the Discord of all the rooms numbered so that you guys can have a sense of where everything is.
Yeah, and also another thing to note is that for our closing ceremony, which will be at 4, we'll be back in here. But just for this other events going on throughout the day, tomorrow it'll all be in that room 1230, and that's literally right down that way.
Yeah, like you said, these are the classrooms. Sorry to jump on you. Day one, we also have the underlined is going to be in the computer labs and the accelerator. So if you haven't been there, like I said, reach out to any of us and we can get you there if you don't have your own computer or need hookups with that. And you'll just need your login, which if you logged on with your ACC information, that'll get you onto those computers. And I was told that some of the classrooms, the doors unlock automatically. So if you see those and there's a chair propping it open, just know that if you come out of that room, the door will lock, and then we'll have to figure out how to get it unlocked. So I'm not sure exactly how many of the rooms. I don't think it's too many, but if you happen to be in one of those, just watch out for that.
Yeah, and another thing to note is that all those rooms are also marked with balloons and signs, so you'll be able to find it really easily. They're all right down that way. Yeah, but I mean, with that being said, let the hacking commence, I guess. So yeah, we have a bunch of mentors here to help you. We have judges, organizers, and yeah, we're all here to help, and we're so excited to see what you built.
So one quick note though, since this is the first hackathon for a lot of people, please help out each other. Again, this isn't meant to be something that's hyper competitive, and we just want people to have a good time and be a good sport and help each other out. We're all part of one big computer science or technology community. And back to the schedule real quick. For the day one schedule, I just wanted to emphasize these workshops. So we're going to have the big ones that I would recommend is the intro to web development, the Q&A with a professor, and the future of authentication. I'm a bit biased. The future of authentication is going to be the workshop that I helped put together with a big person in cybersecurity. He has a startup, and he might be hiring some of you guys. So I definitely be here for the future of authentication workshop, and all the others as well. Again, it's not supposed to be something that's hyper competitive. So come in, have some fun. We have a typing competition, a Smash tournament. Have some fun, and at the end we'll have ice cream before we break. So we're trying to get everyone out by 8:15 approximately, because 8:30 we have to by 8:30 we have to have everything like closed down and cleaned up. So come to like a closing point at around 8 and start packing up to leave around 8:15, because then we have to have everything like cleaned up and set. But yeah, let the hacking commence. It's technically not 12 yet, but we'll give you an extra 30 minutes. And for the second day, if you guys are wondering on how to get these projects submitted, you will submit them through DevPost. And we will also have a, it's like the top 5 teams will come up and present, and we'll vote and based off that. Like we'll vote for the top 3 places based off that. And for the prizes, we have first, second, and third grand prizes, which means like overall based on the judging criteria, who gets first, who gets second, who gets third. And then we have the best beginner hack, and you're only you only qualify for this prize if this is your first ever hackathon. So if you have we have an Echo Dot, and we have a mini projector. We have Galaxy Buds Plus. We have some power banks that we're going to give out as like, these are going to be like mini prizes for some of the challenges. And we also have an Arduino starter kit for all you aspiring computer engineers. And we also have a mechanical gaming keyboard. So tune in and work on your projects hard so that you could possibly win one of these and maybe become a tech startup, a unicorn tech startup. All right. So we'll be outside. If you guys want to go to a classroom, and we'll help you, we'll lead you there. Be sure to come back and check in every once in a while, because this is like a small hackathon. Yes. What was that? Yeah, they're available now.
Yeah, there's a bunch of rooms available. So if you just follow the balloons, you'll find a room. They're all marked. And yeah, just come back here for our intro to web development at 1.
Also, this is our first ever hackathon, so please bear with us. We're like you guys, we're still learning. So if there's any feedback, please let us know. Anything we can improve on, come up and talk to one of us, and we'll definitely get it addressed. Any questions or anything? If you guys have any questions, just come up to us.
I'm going to go as if no one's touched a website before. So first thing I'm going to start showing is how to host your website on a website that people can see, and it's not just on your computer. So there's a couple free hosting sites, and I have this PDF that I'm going to give to you guys at the end, but we're going to go ahead and use Infinity Free first. Tested that one out, it seemed fine. So you do have to register for it. 1 second. So I'm going to go ahead through that whole process with you guys. And then once you register, you'll have access to cPanel, which is how you upload files. And if you guys want to set up a database, you can do that. Your website will support PHP if you guys want to get into that as well. But most of the testing we'll be doing will be local, and then we'll push the website up at the end. So here, let me set up an account real quick. Okay, service, not a robot.
Are you able to share that the website link?
Yeah, I can share it now. Yeah. Let's see here.
I'll send it in this.
Yeah, of course. Oh, actually, I could just show you guys a QR code if you guys want that. Yeah. If you guys want to take a picture of that one or go to the website, you'll see a button on how to access that. Okay. So yeah, if you click the first link, it'll download you the PDF. And we'll talk about the other links here in a minute. But right, so got an email that I need to verify my stuff real quick. Okay. So I noticed this bug yesterday, and I think you have to click resend email twice with this one for some reason. But hopefully it'll go through. And if it doesn't, I have a backup account we can use. There we go. Okay. So now we're in. You need to create an account for your website. So you can have up to 3 websites for this one. And you do get a free domain. So you don't have to worry about that now unless you want to buy your own domain. I can recommend namecheap.com or GoDaddy or even Google. It's about $10 a year. But we're just going to click we're just going to decide one here. So let's do test Rudy. And here's going to be the actual domain. Let's change it to infinityfreeapp.com. See if it's available. Oh, guess it is available. Okay. I don't know why they ask you for password here. It's going to give you an auto-generated password, so don't worry about that. Just put something really basic. Save. So your website is now ready to go. So now you should be able to open your cPanel, and that's how you can upload all your files to your website. So then control and click I approve. And here's an important part. Here's where you're going to get your auto-generated password. So I'll move this around here. So you would go up here to your account and then go to client area. Then click manage. And then you have your username here and your password here. So you can click show and hide to display it. And once you have that, you're going to be able to log into your cPanel and upload your website files. So once you got that saved, go to control panel. And online file manager. Okay, and here's where we put that password we just saved. So copy and paste that, and then click keep me logged in so you don't have to log in every time. Okay, save password. So now we have access to our htdocs directory. So your main website root is going to be in this folder right here. So you go to htdocs, and then as you can see here, a message tells you, all right, this is where your file should go. So let's test it out, make sure everything works right. So we're going to create a new file. Call that index.html. Save. And let's just add some code. Going to put some basic, let's do a paragraph, and let's put the words. Okay. And then you save this by clicking save. Boom. Close it. So now we have 2 files, one we created and the one that was auto-generated. So if we go back to our main control panel to access the website we created, let me just go back and double check the link we have. Accounts. Okay, website for testfree.infinityfreeapp.com. Okay, so now we just copy that. Go up here and we should see that code we just created. Nope, guess not. That's not mine yet. So maybe it's not up yet, but we'll go check it later because sometimes these things do take a minute for them to appear. Oh, I think that might be it. Let's see if it worked. Nope, not yet. Okay, so we'll come back to that one in a minute. So I think our website's like being generated at the moment. So let's get into coding. Since I know most of you are intro or beginners, so we're just going to start something really basic. We're going to make a form. So that form is going to change a little as we're working through this. So personal, let's do this one. So if you don't have an IDE or an editor, I would strongly suggest using Notepad++. That's how I learned how to code. It's very simple. It's basically like I'm not going to use it, but it's basically like a glorified text editor. You can add syntax and stuff like that, and it will show you all the different functions that you can use. It makes it easier to code on there, but we're going to be using something called the VS Code, Visual Studio Code. That is also free, but that is a more fledged IDE. So you can do other stuff in there too, like connect to servers, connect to FTP servers, and just other fancy stuff. But let's create our basic HTML file. Yes, okay. And open with code. Okay, so this is what VS Code looks like. Right now we have nothing, so let's just do something like just to make sure this works as well. And now we're going to start editing this locally. So to do that, once you have your index.html file with whatever you want to put in there, you can open it with your browser using right click, and you click open with, you click Google Chrome. Should take a minute. Oh, it's already open. And there you see it. That's how we're going to be working locally. We're just going to be refreshing this page every time we make an edit to that. There's another way you can edit this page without having to edit an editor, and it's called the Chrome Inspector tool. So this is what I use every day at work. If you want to test things out before actually making changes to your source file, you can just right click and click inspect. And this only works in Chrome. I'm sure there's other tools for other browsers, so you'd have to do some research on your browser, but I strongly suggest Chrome. So right click and inspect, or you can press F12 when you're open on a tab. And as you can see here, it's our rendered code. Similar to what we have here, except Chrome adds these by default if you don't have them. So if I change something here, double click, click enter, it updates right here. But obviously we didn't change anything in our source file. So once I refresh it, it's that. So it's more of a temporary edit that you can use to test out CSS and just do quick edits to see how a page will look. So we're going to be using this a lot too, to be testing our stuff. But let's start with some form elements now. So we can display stuff by just adding it in certain tags. So P stands for paragraph. You could do header as well. That. Okay, and then we have P. Click save. Go back up here. Refresh. So you see, and then these tags aren't so strict. So you can change these to look like whatever you want. So let's say we want the header to be a different font style, or we want it to be a different color. We would add styling to that. So to add styling, you can do a various amount of ways. So in our index.html file, we're going to add a styling header. That way we have an inline style within the actual HTML file. There's other ways you can do this. So you could have your own .css file and reference it here. We're going to do all this in one page so you guys can see it all at the same time. So we have an H1 target here, right? Let's say we want that to be the color red. We would target it by doing H1 and then brackets. And then we start adding some parameters. So color, just make it red. So effectively, H1 is going to be red. Just double check that worked. Click refresh. Boom, it's red. And you could do other stuff to it. But now we're going to, since you already saw how we can do it on the code, let's see how we can do it on the fly with the editor. So here our code is appearing here just as well. Let's say we want the spacing to be a little more. So do margin bottom 50. See that change? Or let's do 100, 1000. So margin is one of the ways you can use to add spacing between elements. And you don't have to specify it like this. You could be margin bottom, you could be margin left, div tpx. Sorry, I forgot the pixels. Let's go here. So here we have margin, and if you hover it, you can actually see the margin. So you see the orange, that stands for margin in Chrome. If you add padding, it's going to be in green. So let's say I want to add padding bottom. You see added more space, but there's a difference between those two. There's margin and padding. That's always something that confuses people, is what's the difference? You know, obviously you can see it's green there, the 50 added, and then the other 100 added, and the orange and the other orange on the left. But the difference is that margin is spacing around elements, and padding is kind of making that element a little bigger. So, you know, something I like thinking of is, you know, whenever you're like, it's cold and your mom is like telling you, hey, you can't leave, you need to put on more padding, you know, put on more layers. That's what I like thinking of padding as well. And then margin is just a space between things. So that's an easy way of adding spacing between different things. You can specify exact pixels. So right here we're specifying 100, 50, and 50. Let me get rid of this one just for now. And we're specifying the location. So left, bottom, right, or up. And same works for padding, but you could also do percentages. So let's say we want margin left of 50%. That's going to be 50% of the page. So one second, let me move my screen a little. Oh, I can move that. Look at that. Boom. So as you can see, I have 50 space, and you see it's not quite even. And the reason is because you're pushing it to left of 50% of the page. So the first start of that element is at the middle point of the screen. So if you want to center something, you could do this trick called setting a margin of 0. And to that, we disable all these. And then, okay, so I think I need a parent for this one. One second. Actually, yeah, let's change our code a little. So a div is basically a container. It can be whatever you want. You can make it a box. You can make it a, you know, floating thing, a pop-up. They're the basic building blocks of building stuff in HTML and CSS. You know, they're basically the same thing as an H1 or a P1, but with different settings defaultly applied to them. So we're going to add a div, and we're going to call this our container for our form we're going to be building. So let's call it container, and then let's put our stuff in here. Boom. Right, so now our stuff is wrapped in a container, but the container has no settings to it. We just added something that gives it a name. And there's two different ways of naming elements. You could add a class, which is more of a style-based thing. So you can kind of give it attributes that can be shared. And then you can give it its own exact ID, and you specify that with ID, my container. So per IDs, you can only have one element for every specific ID, but you can have multiple elements with different specific classes. So to specify a class, you would add a period right before the name. And then if you wanted to specify an ID, you would add a hashtag and then the name, just like that. So we have a container, but as I said, we don't have any attributes to it. So if we save this, we load it, we shouldn't see much of a difference. It should be exactly the same as it was before because our container is empty. So, but if you look at the inspector tool, you can see our container there. So you see here it changed as well. And now we have a container, and that's our container, and it automatically gets filled in by the stuff in it. So header and paragraph, and that's all that's in there. So let's say we want to push both of the things to the right. You know, we don't have to do that specifically for H1 or a paragraph. We can do it for the container, and anything in the container is going to move along with it. So if we add a element here to the container, let's do margin left. You can see both of them moving at the same time. So I hope this is making more sense, whereas what the term container means is that you can kind of layer things in different ways and just format things way easier than having to do every single element at once. So it saves you a lot of time if you want to apply different styles to everything. Another note to have is if you have a container and you have things in it, you can modify the things in it as well. You can be very specific with that as well. So we have a container and we're gonna add some spacing. So, and something I didn't mention about padding and margin is you don't have to exactly specify left and right and down and up. You can put it on one line and omit that word. So if we have a padding here, we can add the things in order. So I think it's a top, and then it's a left, and then it's bottom, and then it's right. So this would be the top one, left one, bottom one, and then right one. And that does the exact same thing as labeling them itself. So you can save some time with that. Let's make some background color to this. So let's make it gray. Save that. Click refresh. There we go. As you can see, we use padding instead of margin, so the color still changed. But if we switch it to margin, the color would not be in the edges anymore. Boom. That. Let's click refresh here. There we go. Now we have a more centralized element. So let's click inspect and container. You can see it's orange because it's margin now. Let's see here. So as I was saying, you can target things very specific ways. So we have one paragraph right now that's inside the container. Let's say we have one outside the container. Save. Here, click refresh. So as you can see, this doesn't care about any of the stuff in here. But what if we want to change some paragraphs, but only the ones that are inside this container? We would, in our code, we could do something like this. We could do .container, then space, and then p. So what this is telling CSS is, hey, there's a target before that one. So let's look at that first. So only anything that is inside container and that is a p is going to be affected by these brackets. So do that. Let's click refresh. And as you can see, this turned green as well. It's kind of hard to see, but you can see it a little. Okay. So that's a couple basics of how to move things around and how to change certain elements. The reason I brought up these hashtags, the IDs, is because you use them a lot with JavaScript. And JavaScript is what's going to let your website come alive. You know, you can add forms to it. You can add event handlers. You make it so when you press a button, something happens, something changes. JavaScript is used in almost every website you can think of. So it's a pretty fun concept. So let's get into that a little bit. Go script, and then let's add a function. Let's call it my function. Function my. And then let's have it alert message. So whenever we call my function in this code, this will send a pop-up message through our Chrome. So now we need a way to trigger this, because once we say this, it's not going to do anything because we declared it, but we're not really calling it anywhere. So let's add a button. And say, click me. So here we're starting to get into inputs. A button is one type of input. There's various inputs, and we're about to go through a lot of them, but not all of them. So now we need an event handler that happens whenever somebody pushes this element. So you can do that with onClick. With onClick, we're going to do this. So now if somebody clicks the button that says click me, this is going to run this function, and then it's going to run this command. So click save. Go up here. I have a click me button, right? So if I click this, I get this message. So that can be really useful if you guys create a service on a website that wants to alert people with certain increments, or stuff like that. Once something is done saving, you want to alert the people. This is going to pop up. If you've been on another tab and this happens in the background, it's gonna kind of warn you and be like, oh, you need to go to this tab and needs your attention. Something's like an emergency is happening. There's other ways of doing similar stuff like this. If you use alert, it's always going to look this way. You can't style it, but there's other things called modals, and we won't get into that as much, but I'm going to show you guys what it looks like. And that's basically any pop-up that is styled and looks pretty and stuff like that. And if I click here, you see it's a pop-up. And I'm sure you guys have seen this with websites, saving and forms like that. Usually people have a form you can save stuff to. And it kind of like makes the background like gray. So these are also another way of alerting things, except they're more vanilla based. So you're creating it from scratch and it's not really built into the browser. So the way you would do that is you set a styling element to this. So there's a styling element that I didn't get into, but I can go into now. It's called display. So if you set the style to display to none, it's going to hide it. And if you display it to block, it's going to show it. So here we have a container, right? So we have it up here, and let's do display none. Click save. We go back to it. Okay. And refresh. Boom, it's gone. But it's still there. It's just not there. So click inspect. You see our code is still there, but it's display none. So let's switch that to block. And it's there. There's a couple different display options as well, and that's how you can kind of move things around as well. I might get into one if I have time, but these are the two important ones, is either it's there and it's not there. So the way this works is that whenever you click this, JavaScript actually sends a command to add a dynamic style to that box that's hidden, because right now it's there in the code, but once you click open modal, it sets it to display. And then once we click X, it sets it to none. So that's how those work. So let's try to do that here, where whenever we click this button, it's going to hide this and display it. So getting into JavaScript, let's change this to, since we already have this tied in with our button, we're just going to reuse this. Now we start using IDs. So we're targeting this. So to do that, you need to set it. You can use either the word let or var. They both do similar things, but they get more useful as you have layers of code. So we'll use the basic var for now. So var element equals, and here we start using our first JavaScript function, which is going to be a get element by ID. And as you can guess, it does exactly what it's named is. We're getting the element that's called in my container. Let's copy that, put it here. Oops, forgot a word. Okay, so now effectively we can use element to change things to it. So this is going to be held by an element object, and we can use its properties to change stuff. So let's set that to none. So here we're going to take this off, and by default it's displayed as block. So once we click this button, it's going to target this ID, my container, and it's going to hide it. So you see element style, we're targeting the style, and here we have names to all the properties we were using. So click save. See if this works. So it's showing there by default, that's good. And then hopefully it'll hide once we click this. And it didn't. So let's see what happened. I think we got an error on our inspector tool. So here's another useful thing about the inspector tool is you can use it to debug JavaScript. So you see this little X right here, that means something happened. And here it says get element by ID is not defined. So we did that wrong. Basically, what I was supposed to do is I need to specify the document variable first, dot get element by ID. So once we click that, save it, let's Let's refresh the page, reload the code. See if it works now. It works. So how do we get it back? Exactly how we did it, but we changed this to block. But how do we know which state it's in? Because now we know it's hidden, but the code doesn't know that because we're not storing it anywhere. So we can add a variable that kind of stores that for us. So let's add a Boolean. What do we name it? Display status. And let's do true, because by default, we're going to be showing the element. So now we are going to add an if statement here. And an if statement is basically the way the code decides what to do. So you put if, and you add a condition in here. And if this condition, the math ends up being true, then it's going to go through. And if it ends up being false, then it's not going to go through. So if I would do something like this, all the code in here would always run. But if I would do this, all the code in here would always not run. So we need to set this to this. And oh, by the way, if you ever use a variable that's outside the function, you need to put this right here. The word this with a period. That lets you access stuff under the function. So it's going to check if this dot display status equals true, which by default it is. Let's hide it. And let's update that variable to display that as well. So now we're changing it to this dot display status equals false. Okay. Else, so the else statement is going to run if this doesn't go run. So if this doesn't run, then it's going to go to else. You could also do something like this. False. So here we're checking if this display status equals to false, which in turn calculates to true. And that means this block of code would run now. And here up here, that's pretty much exactly the same, except it's doing this. So this and this would go the same way because it is true. But if you can omit it because by default it's just checking for true. So here we have an if statement in case this doesn't go through. So now we need to do the opposite. We need to copy this code, put it here. And then we're going to change it to block so you can actually see it now. And we're going to change this to true so we can update the code saying, hey, by the way, it's true now. So now we have a basic toggling system. So this button is going to be toggling back and forth between true and false here. And as it's doing that, it's hiding or showing the element. So let's test it out, see if it worked. Refresh. Nope. So let's check our console, see what happened. Caught reference error. This element by ID is not defined. Let's check our code. Let's go back. Let's check it one more time. Get element by ID is not defined. Let's see here. Looks identical. Let's start debugging. Let's see if by removing one of these, it still works. Let's comment this code out, save, go back up here. I think it's going to say the same thing. Yeah. Get element by ID is not defined. So as you know, with coding, you always run into issues. Sometimes you get stuck on things for hours, and that's okay. And personally, I've been doing this for 7 years, and I still use Google multiple times a day, like at least 20 times a day. I Google stuff, and a great website I can suggest is Stack Overflow. Oh, that's not the one. All right, I'm not good at typing today. So here you can ask questions and people will help you with them. Most of the time a question you've asked or you're thinking of is already answered. So, make sure, like we're going to debug this one. Let's start searching this error. Copy right here. I am. And see a ton of people that are like, trying to solve this issue. I, at the moment, don't know why it's doing that. It looks fine to me. I've been used to frameworks for so long and I haven't done plain JavaScript in a minute. So sorry, we didn't get that one right. But let's move on and go back to saving things. So let's clear all this out. Or actually, I'm going to leave it there so you guys can use it. And then we're just going to start writing code under it. Okay. Now, let's say we have an input type text. Let's set an ID because we're going to need to grab this data as well. So it's my input text. And that's it. We're going to have a little input here, but let's say we need to save this, whatever somebody types in this input. But here, let me show you guys what it looks like first. Let's save. You have an input now right here. So let's edit this, and whatever we type in there, we want to do something with it. So let's do something where it alerts that text we typed once we click me. So we need to get the stuff first. So var, and then we use document.getElementById again. Okay. And we're targeting this one now. My input ID. And now we use a different attribute called value. This is going to grab the text inside of this because as you're typing, that gets saved in something like this. We don't see it now, but that's what happens in the background. So we use this to target that, and we target value, which is the value of the text you're typing. So let's go back, delete that. So now we want to alert the user what they typed once they click that button. Let's save. Let's go back. Refresh. There you go. Popped up just like that. So we're running out of time and I won't get close to the stuff I wanted to get into. So I'm going to start reiterating stuff that we went through and ask questions at the end if you guys have any. So let's see here. So we got basic functions, right? We got styling up here. We can set it to color. You can change font by doing this size, and let's do 50 pixels. Let's make it big. And then we can change the weight of it, which is going to be if it's bold, italic, underlined, stuff like that. No, underlined is something else. It's called text decoration. So let's make it bold, and then let's underline it with text decoration. Let's do underline. Click save. Go back. Let's change that. There's so many different ways of making things. So I really recommend these websites, W3. They tell you if you go through it, it's kind of like a self-learn pace, and they have these little HTML editors. And as you type here, you can change here. W3 schools. Yeah, it'll be on the PDF as well. And you click run. Oh, that's the title. So the title is actually going to be what's up here. We don't see it here because this is like an inline editor. But if you're making an HTML page, like up here, you see it saying index.html right here. We can change that to be whatever we want. So that would be in the header, which I don't think I have a header specified yet. Save, go back to it. I think that should work. There you go. So that's how you can kind of give your website like a name. That's what's going to show up in Google Chrome results or Google results if you start appearing there. So where's I going with this? Oh yeah. So I strongly recommend this website if you are learning HTML and CSS. They give you so many types of ways of doing things like styling. you know. So we've been going through tons of ways of styling things, changing fonts. You can actually add custom fonts as well. So HTML, CSS. Oh, a link. Link is going to be important. So let's go through that real quick. So we talked about button, but we didn't talk about a link. And a link is like this. So you do A with a closing tag A. And to target a place, you do this keyword, href. And let's say we want to go to Google. Click save. And then once we click here, as you can expect, we go to Google, right? But what if we don't want it in the same tab? That's really important. And since this is a hackathon's more about accessibility, this is how you can open it without interrupting the current page. So you add the target attribute, and you do this one, you do underscore blank, and that tells it to open a new tab. So, you know, working for the county, something that was really big on accessibility was whenever there was a link to a PDF, it needs to open a new tab. That way the user doesn't go away from the current tab. So if we click this, it opens a new tab. So they still have the stuff they're working on, but it goes in a new tab if they need to. So that's how you can target websites. And if you upload files to that web server I told you about, you can do stuff like this. You just need to add the file name. So file name.pdf. As long as the file name is on the same exact directory as the index.html, it's gonna find it. And if it's not, then you just target the folder or stuff like that. So let's go back to uploading the website. So we got a decent website with a couple properties in there. Let's go back and upload it. So let's see if our website has been built yet. It says pending creation. Let's refresh. Active. Okay, so that means we can access it now. So you copy this link. Copy. Let's go here. And there's the code we made earlier. So if we go back to cPanel, to upload your files, you would go to File Manager right here. Click it. And then here's the file we uploaded before. Now we're going to be rewriting this one because we have our own index.html. So I believe the upload is right here. Oh, upload file. And then let's go to desktop, projects. Let's do, I think it's personal. Here's our file. Put it in place. And that's it. That's all you have to do. And your website is active. Click refresh. And now anyone can go to this website and see the code we made. Keep in mind that inspector tool, because if you ever see something that you like on a website and you want to see how they're building it, you can always learn from it. So click inspect and be like, oh, okay, now I see how they did this. This makes a lot of sense. You know, so that's what I do whenever I see stuff that is interesting. I was like, oh, how did they do that? Let's check it out. So there's a couple more websites I was going to show you. These are websites I built a while ago. So if you go to my my website, I clicked in earlier. It's rudycodes.com. You got two links right here, anyaustin.com and foxapp.com. So these are both websites that are built with accessibility in mind. And the idea behind this one was whenever you are new to Austin, you obviously want to go find things to do, right? So the websites that you'd find are usually filled with ads, and it's really confusing to like navigate them. So what this one is, my idea was if you click within 3 clicks, you can get to where you need to get. So let's say I want to go to water. I click one click, and then I can filter. Let's do hiking, and then I click on this one. It takes you to Google Maps like instantly. So that was my idea within, you know, making things as like easy as possible. Did add some other stuff that is kind of fun, but not necessarily important. So like you can change your theme right here. There's one of the modals I was talking about. So it's using the element display block or display hidden. So you can change your background. And what happened in the background there is we're also using JavaScript to change the CSS in the background, and it's changing the image link in the back. So there's an array in the background or a database that contains all the links to these pictures. And as you click them, it'll tell the JavaScript to change the background in CSS. So that's how you can do that. Same with this one. This button does exactly what we were doing with the display and undisplay stuff is you click it and it makes that, it displays more of these instead of just 6. So you click this and it displays all of them. For all of you who want to get more into advanced web development today, you can do stuff like this using plain JavaScript, CSS, and if you want to have a database, I would recommend MySQL and PHP. And I think that the cPanel actually has a PHP. Okay, so here's a PHP for MySQL. So that lets you manage your database or create databases. And it actually tells you pretty easily how to connect to them as well if you use PHP. So we'll leave that for another day. But yeah, these are just some ideas if you guys want some stuff to do. Another one is, you know, I have this web service that created websites for contractors and stuff like that. But I noticed a lot of people didn't want to go through the process of making a call, getting a quote, and just to find out it's too expensive for them. So I added a calculator here. So you go to price list in there, and this is built in JavaScript, plain JavaScript, and it has a list in the background that keeps prices for all these things. So as the users click in, we're making a table at the bottom dynamically, and we're adding a price. You guys are free to inspect these websites and look at the code. I really recommend it if you guys want to get like a head start. And, you know, changing the pages, changes it up here and adds like another, where is it, 6 pages, $600, yeah. So that's more ease of access stuff as well. I think this one also has a, so let's go to anyaustin.com real quick. Another ease of access thing that would be helpful is when you have a long page, you always want to have these buttons down here. These are jump to buttons. And mine just goes from section to section, but that's a really helpful tip for people who don't want to scroll long. You can find how to make this really easy online. So anything you guys are thinking of, just kind of Google how to make this, and then just like the language it is, like, you know, JavaScript, CSS. That'll be useful. That's how I learn, at least, just kind of finding a specific thing I want to build and just learning how they built it. But I'm gonna put up my website again in case you guys want that PDF, and I'm gonna leave time for questions if you guys have any. Yeah. Yeah.
This might be pretty basic, but I noticed that you highlighted a bunch of stuff in your VS Code, and then you immediately like turned it into a comment to take it out as a debug.
Yeah.
I don't know how to do that yet. So that'd be pretty.
CTRL and the slash. Yeah, that was really useful once I learned it. I didn't learn that until like last month either, so don't blame yourself. Yeah. Yeah.
Yeah, I'm curious about the frameworks that you use. Like, which would you recommend?
I would recommend Angular. Angular and React are both very easy to get started with. If you want to go to the website, and then there's always tutorials like there that kind of like walkthrough tutorials that you learn as you're going, and at the end you finish building like a good app that you can use as well. Yeah. Definitely those two I would suggest, because they work off of JavaScript. So they're built on JavaScript, or like a specific type of JavaScript called TypeScript. And if you know some JavaScript, it's going to be even easier to learn those. Yeah. For styling frameworks, I suggest the Bootstrap. That has a lot of like built-in cool components you can use for like forms, so you don't have to style things to make pretty. They're just already out of the box. JavaScript, if you want to do JavaScript but don't want to get into vanilla JavaScript as much, you could use something called jQuery. That's a plugin that you put one line of code on top of your website, you know, script.jquery.com/3.1 or something, and you have access to all the jQuery functions in JavaScript. So jQuery is a really fun one because it lets you do a lot of complex things with a really little code. So those two I would suggest. Let's see here. Flexbox, that's something I wanted to get into, but we didn't have time. But it's basically a way of formatting things on your website easily. So you can have 10 things, but they don't look that right. You know, they're like squished together. But if you put display flex instead of display block or display hidden, it'll actually give you more tools to manipulate those things. So you could put in the container, you could have something that says display flex, And then for each container, you could put something like justify content between, and that just makes everything spread out. So it helps you with formatting stuff. So look into Flexbox. In that PDF I gave you, there's a couple Flexbox links. So if we go here, there's this game called Flexbox Froggy. It's super fun. It's you start out with HTML, but they're like frogs, you know? So here you can, it kind of tells you what to do. And like, let's put it at the end because we're trying to get the frog into the lily pad right here. So justify content. Now let's do flex, and there you go. You know, it's levels. So you get up to level 24. They get more difficult, but it'll really helps you understand flex and how to move things around a website. So I use Flex every day, even with Angular and everything. I think Flex is really powerful too in CSS. Yeah, and it's already built in. You don't need like a external library for it. Yeah.
So is Flex like the near end all be all for display at this point? I know I'm just coming from a very basic web design first semester. Like we use grid and
yeah, there's a bunch of controversy over that. I like Flex because I like understand it really easily, but I have heard that grid is like better in certain ways, you know, but it all ends up, you know, at the end of the day, CSS is CSS, you know, like if you can find a way that or a pattern that works for you, stick with it because you can get even better at it, you know? Yeah. So, yeah. And sometimes it's also good to keep in mind when changing languages, readability. You know, there's other code that makes it easier to do things, but it's really hard to understand and read, especially when they're going back and editing it. So readability is like always important when working with the team because other people can see, oh, this code does this, you know? Another tip I can give you guys when you're programming is name your variables what they are. So try to avoid like, you know, setting variable names like X, Y, B, C, D, you know, name them something like a timer countdown or, you know, stuff like that. That'll really make it easier to read as well. Yeah.
I really like the design on your website. Like how do you go about design in general? Because I'm really bad at design, so I don't know like how do you start?
I'll be honest, I was horrible at design as well until I started working with the designer on my team. You know, I love working with the designers because they give you so much insight on why decisions they make happen. So I can give you a couple tips. So the biggest one is less is more. So try to not bundle things up as much. So you see these big spacings on the side. It lets your eyes focus on the important bits. You know, like I could have gone away where all this is all like super tiny, but since it's a little more spread out, it's easier to read. Contrasting colors is important as well. So because you can see I have white and black, and then once you hover it, it's red. So that helps with readability, which, you know, falls in with accessibility as well. Right now, this is kind of a bad design because the green is really light. So it kind of merges in with thinner letters like this. So, you know, I would go a different way. Like this is better, you know? But yeah, I could have definitely done better with the accessibility part with the colors not marching a lot. Oh, and another good tip for picking colors is always something that takes me a long time. So there's actually a cool tool called Adobe Color. Yeah, exactly. This one's a palette kind of style though. So you can explore trends. So you click here, explore, and you can see so many like this is really cool. You can see all these colors kind of work together, and you can kind of get an idea of how your website will look by just going through this website. So you can also type something like winter, like just any term, and it'll pop up some stuff, you see? And once you click on a palette, click on it, and it'll tell you all the hex codes for the colors. So these are colors you can use whenever you're using CSS. So, you know, color, space, hashtag, and then 6 numbers. If you ever want to change the opacity on any of these 6 numbers, it's the 2 numbers after that. So you make it 8 numbers, and the last 2 numbers are 0 to 100 is opacity. Yeah. So strongly recommend this. You know, you can also, I think there's a tool where you can upload your own image and it creates a palette from it. Yeah. Yeah. So yeah. But yeah, less is more is my biggest tip for design. Yeah. Yeah. I think for me is whenever I start a project, I think of the goal first, and I think of all the necessary components that need to be shown. So once you have your important stuff down, now you can start kind of wireframing. And what I do is I get a piece of paper, and a piece of paper is kind of like a website. You know, you're going to be scrolling down and up it. So just kind of, you know, put like boxes and be like, okay, I want this to be on this side, this on this side. Try to get the frame of like things where you want them to be in HTML good, and then start you know, filling it with color and stuff like that. Yeah, that's the way I go usually. Oh, and also if you guys are looking to make websites, something that I use a lot is templates. There's so many free website templates, and I don't consider this cheating because I do it all the time at work. It's like you get a free HTML template that has all the HTML, all the CSS, all the JavaScript. You just edit it. You know, you take out pictures, you change the colors. You can find a template you like. And if you don't want to code, Wix.com is another suggestion of mine. On that link, you actually select any of these websites and change the content. You know, and there's a bunch of plugins that you can use that you can customize to get data from Twitter, get data from YouTube, get analytics, connect to databases. There's like, you know, the possibilities are endless. But you know, you want to spend more time, you know, just looking at designs. I like looking at these designs, and I kind of get some ideas of how I want stuff laid out as well. So it's always good to look at like you know, what other people have done before to give you ideas. Yeah. Yep. I think that's all the time I have. But thank you guys. Appreciate you guys coming through. Yeah. Yep. Just
Test. Okay, so yeah, that was the intro to web development workshop. Thanks, Rudy, again. Really appreciate it. So we have a channel on the Discord with all of the resources that we shared, and also feel free to claim the time for like the raffle. We'll be awarding 2 raffle tickets for this, and the passcode is template. So yeah, thanks, Rudy, again. I really appreciate it, and feel free to ask any more questions because Rudy is also going to be a mentor. So if we need any help, yeah, he's here. Anything else you want to share?
Okay, my name is Prof Gregory. I teach here at ACC. I've been here for 16 years, and I teach programming and other classes in computer science. I am not here to tell you anything that's going to be necessarily useful for jobs, except perhaps to point out to you that you're probably doing the most important job skill right now, which is working in teams. Okay. Your main job skill is not being a coder. You think that knowing how to program is limiting you in what you're doing now, forget it. If you fill a team with hot coders, all they are going to do is tell each other what they're doing wrong and how I could do it better. Your main job is to be a contributor to a team. Nobody in commercial activity programs by themselves. You will always, in your career, work with other people. And if you can't work together, you're going to have to learn. Walking in with great coding skills is not going to carry you anywhere but into some room that nobody wants to work with you. So if you want job skills, you're doing it right now. Don't worry about the fact that you don't know how to code well yet. This is called Q&A because I couldn't think of what I was going to talk about. So we said, why not Q&A? I've kind of thought of something to talk about since then, although there probably will be some questions after that. I looked at the ad for me, said talk with an amazing professor. Amazing basically means available. I was here, I could show up. So that's me. I'm going to talk about you. Not about tools that you would use, those guys were, that was a really good talk, the things that you're going to need to learn. What I want to talk particularly about is what you will do with your work in the future. This is a pretty specialized skill. It's a pretty useful skill. I tell my students, what you're working with is a magic machine, and it is magic. That makes you a magician, okay? You're learning to give illusions to people that become real. You go to a magic show, you want to see somebody float in the air. You want to believe that. Everything that you see right now is not there. You're looking at a screen, you're looking at a picture. That's not a picture. It's a bunch of dots on the screen. Nothing's moving there. This is animation. They invented that 100 years ago. This is Walt Disney. This is drawing a screen, drawing it again. This is not a page. Steve Jobs made it look like a page. Bill Gates in Windows made it look like a page. That's the only reason you have these now, because there's an industry that sold these things to everybody on the planet. But if they couldn't sell it, you wouldn't have it. And they couldn't sell it unless your grandmother could use it. She couldn't use it unless it looked like something real. Get into a command window, you'll see what programming was. Never had the opportunity probably to talk to old pilots who used to fly in open cockpits and stuff like that, but they would always say that's real flying, okay? You're not gonna listen to me say punching cards, working in a command line, that's real programming. It is for you, or was at some point. That was the only entree into this. I'm gonna talk a little bit about what that is. I have a pedigree. This, let's see if I can bring that up. That's memory. A drum memory from the Iliac 2. That's the Illinois, University of Illinois version of the ENIAC, which looked like this. That's what they built after World War II. John von Neumann was the human calculator of the Manhattan Project. Kind of man who, when he was on vacation, would, when he got bored, calculate logarithm tables in his head. He built the computer you're using now. The same one that ran this is exactly the same thing that runs what's in your laptop right now. It runs what's in your car. It's run what's in your phone. It's exactly the same design. He was that good. He built this machine with Alan Turing, who is the person that designed what you've got, probably the most important mathematician of the 20th century. You may have known him from a movie that shows one of the least important things he did, which was to break the German high command code in World War II, to break the Enigma machine, which he was very good at. But in terms of his importance, is small by comparison. He invented the idea behind this. He proved that it was possible for machines to compute. And in doing so, in order to do that, he reinvented what a machine actually is. Machine is not what you're holding. Machine is not what this is. That's hardware. That's the implementation of a machine. A machine is a concept. A machine is an idea. That goes way back to Plato, if you're interested in philosophy. But in order to prove mathematically that a machine could compute, he had to define a machine as something that you could address mathematically. It's called a Turing machine. There is no Nobel Prize in computer science. The Nobel Prize of computer science is the Turing Award. He is that important. He proved computability. If you know about Kurt Gödel, the undecidability theorem, it's a thing that rewrote mathematics in the 20th century. Part of what Turing did was theoretically prove there was something called a halting problem. There are limits to what we can do in terms of proving mathematically. There are limits, yes.
Is that why there's like a Turing honors program at like UT?
Absolutely. Anything you see named Turing is named after him.
What was his full name?
Alan
Turing.
Alan Turing. He worked with John von Neumann to build this machine because it was his ideas that did this. This machine was Turing complete, as they called it. After this was done, before they were able to finish, Alan Turing was arrested for violating the law in Great Britain because he was gay. He was forced to take hormone treatments for a year and a half, and then he committed suicide. If you want to talk about accessibility, think about that. There are other ways to be accessible. One way to become inaccessible is to kill the people who can teach you. This machine, where is it? Wrong one. Killed my search. Hang on a second. The one I showed you a minute ago might have a bigger version now. This is from the Iliac 1 version of the ENIAC. What happened back after the war, people started building these because von Neumann realized that you had to compute. When they built the atomic bomb, there's an enormous amount of computation necessary. No science was done to build the atomic bomb. That had already been done. What they had to do was engineer something that would blow up. They knew what chain reaction was, create nuclear power, fission, but it just spread out. It heated things. They needed it to blow up. So they had to build this thing that would force the chain reaction in on itself and explode. That was a huge engineering problem. It took them years. They had lots of people computing, rooms full of people computing. How many of you have seen the movie Hidden Figures? Okay. The women in that, aside from the extraordinary importance that they had, I'm looking at, here's another accessibility concern. I see two women in the room. Okay. For all of you who go in and own computer clubs and grab the machines and do all this kind of hiding, how many of them are groups of boys or men when you're in high school? There's another accessibility concern. I've been involved with quite a few programs in the last 40 years about the idea of women in computing. Huge amounts of money, huge amounts of programs, focuses from universities, government, industry. And the number of women in computer science over the last 40 years has stayed flat. None of it's working. Lots of money. What they keep thinking is we'll put some more money into it. We'll do something else. I've been telling people, you know, nobody's talking to the men about this. Everybody's saying we got to find more ways to get women into access to the machines and stuff. Well, who owns those machines? Everybody's going, okay, yeah, it's the boys seem to cover it in middle school and stuff like that. Somebody talk to them. Some of you talk to each other, to your friends, to your brothers, somebody else that's in there. Point out that 50% of this country is not contributing to this development. I'm on a tangent. I want to get back to this thing. Accessibility is what we're doing here. When you're thinking of software solutions, there aren't too many software solutions to what I just said. But use this as a springboard. Your experience here should take you somewhere. I'm going to talk about some other things to take you different directions. I'm bringing this up because my father worked on this machine. This is my pedigree. I don't know what you all played with growing up, but I played with punch cards and paper tape. Yeah.
So would you say that your father working on this piece of machinery is what inspired you to pursue computer science?
I'll get to that. Okay. This is an example of what was going on in the 50s, which was everybody built their own computer. Okay, by 1952, I think when this was built, when they first built it, there were maybe 50 computers on the planet. They filled entire floors of rooms. They were, you saw what that one looked like before. Everybody built their own. There were no standards. If you had a university you wanted to work on this area, you built it. You know, this was called the Iliac because it was a von Neumann style machine. There were others that competed. You built one that worked for you. And after about 10 or 15 years, everybody realized these are going to have to start talking to each other, the government, space program later, those things. So they started having to develop the standards that we now work with, common languages, things like that. But they didn't start out that way. This was in the math department. This is not in, was not in the computer science department at the University of Illinois. There was no computer science department anywhere. Everybody were mathematicians, engineers. They said, hey, we've got to get these machines. Let's build one. Let's help it make us, oh, my point about, I'm sorry, I did want to make a point about hidden figures. Those women were the computers. Computers meant people. This was an electronic calculator, then later an electronic computer. But von Neumann realized rooms full of people computing wasn't going to make it. That's why they built these things. That's why they needed them. That's why all these departments started each one building their own. Okay, they did that at the University of Texas in the math department. My father was a professor of mathematics at the University of Texas. There was a man named R.L. Moore. If you go down on 26th Street, there's the RLM building named after him. Very large world reputation mathematician, pure mathematician. When my father and his colleague David Young were professors there, he told them they were just engineers because they were numerical mathematicians and they had worked with these machines. They didn't belong in the math department. And they basically said to each other, yeah, you know, we don't. And everybody at universities all around the country said the same thing. You know, we need our own department. We've got theory here. Turing's mathematics was really theoretical computer science as well. So everybody started building those. MIT that came out of the linguistics department. All kinds of places. So part of my pedigree is my father and his colleague David Young created the computer science department at the University of Texas. They flipped coins as to who was going to have to be the chairman. My father lost, and so he was the first chairman of the computer science department. Yeah, so I would say I was interested in that. I played with them as toys, okay? I learned to program by taking a Fortran course at when I was 16 and turned that into a 13-year career because nobody knew how to use these. So if you could write even the simplest kind of code, you could get paid for it. I went through school at UT when my friends were turning burgers or serving people at McDonald's. I was making 4 times the amount of money they did for writing code for people who didn't realize that it didn't take me that long to do it. You could do that then, okay? They were magic, and I was the magician, and everybody loved my illusions and paid for it. If you have a history of coding and you've been hacking yourself out, hackathon, okay? Hackers didn't mean people who stole stuff or put in viruses. Hackers meant people who just kind of hacked out code. You know, quick and dirty, got it out, got the job done, those kind of things. I have the experience of 13 years worth of making a living doing that and then hitting a ceiling. Realizing that I didn't know enough. I was doing community development, city planning, didn't study computer science as an undergraduate, but I hit my ceiling and decided, well, I think I'll go back to school. So I did. I was doing community development in Knoxville, Tennessee. There happened to be the University of Tennessee, so I went to grad school there and was immediately told my code sucked. This is garbage. We can't use this. We can't work with it. You have to write this way. And for a year, I was really not happy doing that. So I know when I have students who rebel against that stuff, I know exactly what it's all about. It's about feeling like I know how to do this code. Why do I have to do all this other stuff? Why do I have to design it in such a way that I have to tell somebody who's stupider than I am how my code works? Anybody felt that? Recognition? Yeah. Okay. Reason is, if they don't know what's going on, then you're in that group where you've got 4 hot cutters trying to figure it out and somebody's saying, okay, we're going to do this. No, do it that way. Oh, look, I'll do that. No, I want to do it that way. You're going nowhere. Okay. After about a year, I realized that you can't design good code unless you design good code. I've been here with groups telling everybody, write down what you're going to do first. Don't start typing. I tell that to my students also. Something happened in 1990, give or take, 89. Most of you, pretty much everybody here, has no conception of what it felt like to live in the world before you had all these machines. So I'll tell you, and you won't really get it because you haven't felt it, which is fine, because I'm not supposed to still remember what my grandfather used to tell me about, how you had to ride horses. We don't need to know that. You don't really need me telling you what things were like then, but I'm going to kind of anyway. By the way, if I hear, okay, boomer, remember I'm a judge. So the world previously had tools. It existed as a certain way that pretty much, I would say, almost from 1930s to the 1990s, didn't really change that much. There was technological advances, there was the Industrial Revolution. There was a guy named Alvin Toffler who wrote a book called Future Shock about how fast things were changing, how hard it was to do. It looks almost naive what he was saying now, because during all that time, the basics of how people operated still were more or less the same. How many of you missed a phone call? Yeah, really? Okay. You mean somebody called and you didn't get it? You had an answering machine get it, right? You got a message? How many of you have had missed a phone call and nobody got it? They did not leave a message. There was nobody there to tell you. Okay, that's normal life up until somebody invented these little things with tape that would take a message. You still had to go find a phone if you needed to call somebody. If you wanted to find your friend, they weren't answering, you had to go find them. There was no instant contact all the time. These were our tools. Somewhere in 1990, as this industry came and started growing, the tools swallowed what had previously been the society that was using them, and now they use us. He just connected to all your computers through Zoom. That's how you took notes. Didn't really take notes. You kind of recorded it or something so you can come back and look at it later. I'm still trying to figure out this Discord thing they put me on in order to be keeping in touch. It's not going to work. I'm not going to be able to keep in touch with you, but I'll try. Okay? A complete paradigm shift. All of that's leading up to this question: what kind of impact are you going to have with this skill? What are you going to be able to do? And I'm basically saying not much, because it's not that magic anymore. You are basically the last chance to have huge impacts with this skill. Because 30 more years and you're basically maintenance people, which are important. Everybody's got to keep everything running, but you're not having to invent it anymore. Probably the last group of people who are really going to, your younger siblings or your children are going to learn to code in the 2nd grade. They're going to write everything you're trying to write now to solve this problem. They're going to learn by the time they're out of the 2nd grade, because there is at least movement that believes that reading and writing and arithmetic and coding are all the same level of skills. And 7 and 8-year-olds are going to learn them at the same time. So this is not going to be magic. So I've got a challenge, first of all. That's why I brought this thing up. None of you can read. None of you knows how to read. None of you are capable of reading. And if you didn't realize that, you need to realize that everybody who's teaching you and everybody who is, I'd say, 50 years or older, who are in control of a great number of things, absolutely believes that. I hear it all the time. People talk about it. Nobody reads anymore. Students won't read. They don't listen. You can put stuff up, they won't read it. They all gripe and complain about this and put you all in that category, and they all blame it on, my generation, they blamed it on television. Now they blame it on the games and the computers and everything else. You're just visual learners. Nobody knows how to read anything. Here's what I'm going to, let me see. And where did this save this? I forgot to set up.
Click on the file over
No, I need the file itself. So it saved it probably in, and where's the Explorer? I need to go out and find the Explorer. I need to go out on the disk, basically. Where am I here?
click the magnifying glass. And then
Yeah, you're right. Sorry. There we are. I'm guessing downloads. There we go. I'm doing, for those of you who took 1301, I'm doing one of the projects out of the MindTap book. I'm going to basically, if you've done this and done any projects, this is a tool where you can do projects, submit them many times. It will evaluate what you did. I just completely failed because I didn't do anything to it. But I wanted to show you this, and I'll have a number of things to say about it. When you submit it in MindTap, it gives you a study guide. And where did I put it? Which is access into the textbook related to the project you're supposed to be working on. And one of the beefs I have with these people, I have a lot of beefs with Cengage. If you've taken 1301, if you took it from me, you've heard this. But he left, actually, Chris Petterfield. It is relevant to this that the book company that published this tool didn't realize that what you're looking at here is instructional. Okay, here's the paradigm. It's been going since the 15th century, certainly in the United States since the middle 1900s, absolutely since around World War II, which is the way you learn. You read a book, you listen to me talk, you take notes, you go home, you study what it was said, you come back in here, I take away your books, I take away your notes and ask you what you memorized, okay? Now, that is based on an idea of how people learn that is primitive, to say the least. There have been so much research that we've learned in the last 100 years, certainly in the last 20, that tells that's actually how, not at all how people learn. If that was true, I'd unscrew your skulls, get a salt shaker full of knowledge, shake it in there, and you go home. And you would know things. But that idea is so prevalent because people were taught that and learned that the people who are now in control of putting together these tools are being handed technology of a sort they never saw and of the sort you are still in position to work with and manipulate, and they are still trying to make it fit in that old box. So these instructional tools are there in case you fail on their test of doing that project, then you can go and look up how you should have done it. Okay, I cannot imagine why this wasn't available to start with. You actually have to fail something before they will let you do it. Here is what I want to show you about one of the things that I would encourage you to think about doing. Oh, see, there's an important word, remediation. That means you didn't do well enough and you're going to have to review. Here's what they expected you to do. They expected you to read this book. Okay, there's a paper version of this book written out this way. This is the kind of thing you would read, kind of thing book publishers think they have done marvelous things with just because they can put it on a screen now and you can page through it. I think they've accomplished something fantastic. Somebody needs to tell them this was great work in 1990. Okay, converting documents for use in PowerPoint. Insert slides from an outline. By the way, what you were saying before resonates with this too, in terms of the question you asked about design. When you take a course in PowerPoint, they show you something that's already there and tell you how to manipulate. They don't tell you how to start from scratch at all. And what he said about laying the design out, think about movies. They start with storyboards. That's what he's talking about there, okay? Right, I have to tell my programming students all the time, don't start typing, draw stuff. I was telling people in teams here, write up on the board, okay? Starts there. And here's what's going on when you do that. You're wasting time. You're having to try to fit something onto a page when you should be thinking of what you're gonna do. That's why you draw, you can draw. You don't have to think about that, yeah.
Yeah, I think a lot of times I have like a problem with like planning out too much even, like especially like in hackathons, like I find myself like, I remember a hackathon where I've been in the past, we were working on a project and I was like working on a project for like basically 50% of the time just planning it, and then we actually started coding. I think the planning portion is like really important.
I will argue that if, okay, here's a rule of thumb. There's a guy named James Brooks, I think, wrote a book called The Mythical Man Month. He studied the development of the first IBM supercomputer. And he gave a rule of thumb. Great book, talking about all this now. So here's, though, a rule of thumb I've used ever since. 1 hour of coding, 2 hours of design, 2 hours of debugging, 2 hours of documentation. You got to think 1 hour of coding, you got to think 7 hours of work to make that go. Every 2 hours you spend on the design drops your code in half. That's the way I would see it. If you spend an hour on the design, you've dropped the coding time to like 15, 20 minutes, half an hour. Everything you put into that, putting your brain on paper, putting your ideas on paper, getting it worked out first, save yourself the time on the coding. That's what they do in movies. They're not paying those actors and people with cameras that kind of money to stand around not knowing what they're doing. They lay out the storyboards. They get everything there. Actors will talk about directors that come prepared. They can't pay those people that much time to figure out where you're going to stand. You know, you were saying which side of the screen you're going to put it on. They're not going to walk out there and say, oh, maybe you should be over here. They better know ahead of time where they're going to set up. At any rate, here is reading as they say it. Here is what they call a training.
Insert slides from an outline in another file to automatically add the information.
I'm going to let that go. She's just reading what's up there. Okay. I can speed this up a little. Okay. She said what to do. On the thumbnail plane, click this. I'm going to watch it happen. I'm going to try to, I can speed this up a little bit. Okay. Shows you how to pick this thing up. Oh, I actually brought this up here so I can point. Yeah, nothing to point out now. Okay. In the slides group, notice the cursor moves there, showing you what's going to show up. Okay, let's do it, showing you those things. I can't fast forward through, so this is actually a longer one than I was hoping to get. But this is what's called an observe step. Notice these three lines up here. Observe, practice, apply. So we've observed this whole thing. Stepping through, I tried to speed this up, still going slowly. Click and say, this better be it. Shows that that is what got inserted. Really did pick the wrong one. There can't be more steps to this. That's telling me it's start taking questions because there's no clock here I can see. I still got 20 minutes. Moulin Rouge, by the way, for any of you who didn't recognize where that came from. It's still going. Oh man, did I pick the wrong one? What I wanted to be describing about this, okay, there we are. The process, we just watched that, okay? There's now a practice step. Same thing, talking about this stuff, describing what's going on. In the thumbnail plane, click on the blank space. Now it's waiting. It's not going to show me how to do it. Now I've got to do it. What I just saw and observed, now I've got to practice the same steps. And then once I've done that, through that whole process, then the apply stage, I hope it'll go. It just tells you do that stuff and then you do it on your own. 3 steps: you observe, you apply, you practice, and you apply. There is one of those trainings. For every topic, subtopic page in this book. I use those trainings as reading assignments. Why read the book when you can do it? The learning curve on that goes through the roof. You can't read, according to all of my colleagues. Thing is, you can't read the way old people read. This is 21st century reading. That's what one of these trainings is. Beef I have with Cengage, they had even better versions of this 10 years ago in something they called CourseMate, with exercises they called student edition labs, they were better than these. They covered all the content. Some of you were talking about how that course is just a literacy course in terms of the hardware and technical aspects. They had exercises that taught those technical. I had students, English students, nursing students who understood binary numbers from doing those kind of trainings, and they've thrown it away because they still are trying to fit this technology into a 19th century idea of how you learn. This is hard to write. Believe me, I worked in 3 different educational software companies. It's expensive if you want to do it right. It takes the time. It's a very competitive marketplace now. If they want to produce this kind of stuff, they have to beat out some other company to get it there. It's expensive. It's hard. That's why you don't see more of it.
Which companies did you work for?
Kind of private companies, actually. One called Generalware, one called GW Software. We kind of made them up, basically. We were writing those. I started out writing educational software in a educational laboratory at the Ed Psych department at the University of Texas, where we were doing the basic research for how people learn, how they interacted with these machines. Okay, we were the only place on the UT campus that had screens and keyboards in 1968, and we were building this kind of stuff. The stuff we did is the stuff they put in, they reference in the books. Yeah.
I really like what you showed about like the different ways to learn, because like how it's changed so much. And even like this, as like observe, practice, apply. I feel like in the future that might even change further.
You're going to change it. That's what I'm trying to say. If you're going to do something with this skill, consider that. If you want to increase access to education, what's education? Is it memorizing this stuff? Is it learning how to do it? I don't give multiple choice exams in my programming course. That's useless. I didn't even know what a sentinel was until I started teaching. I still don't care. Okay. If you have parameters to a function, some people call them arguments, some people call them parameters. Some people actually say that it depends on whether it's the calling or the definition. One of them is an argument, one is a parameter. What the hell is that supposed to mean? Why does that make a difference? We call them flags no matter what. It makes sense. It does no, this is not a memorized skill. You don't come in and cram the night before for an exam in my class. My exams are, you have to write a program. They're in class. Solve a problem. That's what you're doing if you are a programmer, if you're a software developer, if you're a web designer, if you're working in networks. You're solving problems with this technology. Learn how to solve them. Consider some that make a different kind of difference than just being able to maintain the tools that everybody is going to use. This is one of the last areas in which you can do something that really isn't going to be the ordinary business of life. Just to cover up my notes here. Hang on a second. Here's another in terms of access, since that's our theme here. I thought of one other thing I wanted to show about that. How many of you have taken a class in our lab classrooms? We're kind of working in some of those now. See those in the rooms that we're in? Computers at every desk, that sort of stuff. Okay, I want you to know how unique that is. Okay, I taught at Texas State University. They basically have these big rooms like this that you talk about, and labs are something separate. A lecture, you learn all that stuff I was just telling you is unimportant. You write it all down, you go out, and then you work in a lab somewhere else. We have a facility where you can sit at your desk, like you all are doing now, at your computers, except they're all networked. As I'm teaching, I can share stuff onto your screens, kind of like he was doing with Zoom, but they're built into the rooms here. This is a very unique and very special learning environment for programming here. Take advantage of it. You know, you transfer to UT, you're not going to find those rooms. There's something called a digital Oh, missed that. That's an access. Okay. Y'all can't write a project for that yet, but that's some version of access that's not, that's in the room itself. Digital divide is not, I don't know if that's a term people use now. It's certainly when the industry was building, people talked about that a lot. It was like, what is going to happen to people who don't have this technology? Right now, it's people who don't have good Wi-Fi, because we assume everybody's got this stuff. So if you have a problem with the city or something, they'll tell you to go to a website. Well, guess what? Not everybody is connected to this, okay? Less than 50% of the world still doesn't have anything like this technology. Okay, cross the digital divide in some kind of way or another. This guy, 10 years ago, longer now, Pranav Mistry. I first saw him on a TED Talk. He had developed this thing called a wearable computer. Let's see if that's it. Yeah. He had built this at MIT. It was a gesture maneuvered computer. He's got and these are off the shelf stuff he was demonstrating. He's got a webcam. He's got a projector that's shining light out of there. He's got tape on his hands. He's got a computer in his backpack. And what it's doing is it's projecting this screen on the wall. Okay, you're just seeing my screen here. What that device does is it projects a screen, and then instead of the mouse, it tracks his fingers. So it's a touch screen, except he's waving in the air. Amazing device. Didn't go anywhere because it was not commercial. Got into a whole lot of other things. What he really got into was this idea of accessibility, developing tools that could be used in rural India. Think about that. That's a different kind of access than we're looking at. And yet it is not completely isolated from the kinds of things people encounter here in this country. Last chance to do something special with this technology. 10 years from now, you'll buy some product off the shelf. You're already buying products off the shelf that were magic 20 years ago. Final advocation, and then I don't know if there are many questions left. In terms of what you're going to do, I mean, we can't all go out and make some kind of huge difference. Like I said, not that many huge differences to make anymore. And you're not necessarily going to go out trying to meet some social goal or something. I mean, you want money, you want to live, you want a family, you want all those other kind of things. I used to talk about doing what you love in classes, and I remember being kind of brought up by someone who said, I've had to sacrifice a lot. I've had to do stuff I didn't love in order to be able to survive. And that I learned that I was devaluing that kind of effort and that kind of dedication by saying, do something you love. Do what you have to do if you must do it. If possible, do something you love, because you're going to say every day through a career, maybe not so much anymore because people are at home, but I'll use this phrase anyway. You're going to get up and you're going to say, I've got to go to work, or you're going to say, I get to go to work. You say, I get to go to work, stay in that job.
I mean, it's all about
Right?
what you enjoy, what you have to do.
Because that will keep you doing it. This is a crushing. If you've already done this, if you're up all night, you're all going to hack all night. It's going to drive you nuts. You're not going to eat. You're going to be stressed out. You're going to be worn out. You're going to do that to yourself for 40 years. You better love what you're doing. I thought these machines, I tell you, the first program I ever wrote, it was in Fortran. And it was said X equals 5, and it said print X. It was 2 lines. And I saw a 5 come out on a printer paper, and I was totally hooked. It's magic. unbelievable that the machines are doing this. Back in then, nobody imagined that these big rooms full of computers can do the stuff that they're doing. Now nobody's thinking that. They're just trying to calculate. You can replace electronics with software. You can run your washing machine with software.
Have you heard of that dude, Eric Demain, MIT? You can look him up. He's big. He made he's like a child prodigy who was really into origami.
That's spelled right? There we go.
Yeah,
Okay.
he was a child prodigy who was like super into origami, and this is about like doing what you love.
Yeah.
He was so into origami, he became a computer scientist, and he developed like an algorithm that finds like a paper folding pattern to create any origami 3D shape, anything, like a sphere,
Yeah.
anything like that. It gives you like within mathematical uncertainty,
Yeah.
which is like unheard of.
Mathematicians will tell you, well, my father was a mathematician. I grew up with this. I was never allowed to ask, what's it for? Ever. Mathematics is pure and is its own reward. It's its own justification. All of this is. Okay, mathematicians just get interested in something and they follow it. They don't feel like they're having to do something else. Some guy is into topology and just goes out and starts imagining ideas. This guy was into folding, okay? If you can do that, that's great, okay? Can't necessarily get as close as you can. Find anything. I try to find students in my classes that have studied anything else, because you get so narrow into engineering, things like that. Okay, what do you like to do outside? There's a paper airplane. I came for the paper airplane contest. I really want to see this. Okay, I studied liberal arts as an undergraduate. All kinds of other things. I played the drums, played guitar. Anything you can bring in from somewhere else enlarges what you can do with this. Nobody imagined that this technology could do this kind of stuff. It's not finished. Okay, take it somewhere if you can. Do it. Do things that you love. You can find things that motivate and that you love in any kind of job. If a job is crushing you, consider getting out. You may have to sacrifice. Don't do anything just for the money. Don't do it based on you ought to do it. There needs to be at least a third reason for why you are going to get involved in this stressful and hard process. Okay, I guess that's it. Anybody got questions after all of this? I should have been a minister, actually. I could have preached pretty easily. How's it going with the
What courses do you teach other than 1301?
1336?
1336?
Yeah.
What's your favorite programming language?
Well, I'll tell you this first, okay? I've programmed in at least 20 different programming languages over my lifetime, okay? I don't care if you know Python, if you know C++, if you know Java, you're not gonna program that in 2040. Won't be here. How many of you heard of COBOL or Snowball or Lisp? Okay, those were the main languages in the 70s, certainly for AI. There is no perfect programming language. It depends on what I'm wanting to do.
C have been here for a while.
I did most of my work was in either C or in Pascal. Pascal was what they ought to be teaching in 1336 because it was invented strictly to teach, but it has no real commercial potential, so nobody's teaching it anymore. Python's hot stuff that people are using. That's what you do as the intro allow. As I tell most of my classes, anybody that has heard it, Python is a quick and easy language, so they say, but it's loaded with landmines as you write it in. It's a poorly structured language, and the quick and dirty stuff you throw in will come back to bite you a year or two down the line. It's not a heavy duty industrial strength language, no matter how much industry it's involved in. And that's why it won't be what you're writing in 2040. The industry redefines what's important. Somebody gets a new application in some language. Suddenly, if you want to do anything in that area, you work in that language. There are now higher level languages where you're really working through platforms. You're working through templates, you're working at levels where you're not actually writing the code. Some software tool is letting you design, it writes the code, which then feeds it to a compiler, which then changes the code into assembler, which then feeds it to an assembler that then converts it into the machine language. And so it finally runs. And that at every one of those stages, you lose efficiency because you've got an algorithm, a program that is figuring out what your words should turn into in these lower level commands. So that used to be impossible to use to develop until the industry came and memory got cheap and clock speeds got faster. And instead of making more efficient programs, you said, just put on the boxes, this requires 650 megabytes or however much memory, how much clock speed, otherwise it won't work. So hardware is buying off the efficiency of languages. At some point, I believe that's going to run out, probably not in my lifetime, but you never know. But of all the languages, see, if I had to come to one, that's what I worked most in, and that's what still feels right. Although C++ kind of is, you can move into that fairly easily. It took me a while to accept the idea of object-oriented programming because it violates, code in the 50s and 60s was so poorly structured that in the 70s, there was a movement by Dijkstra and Kernighan, Plower, those people, into something called structured programming. Principles of structured programming were a complete rewrite of how you designed things. Instead of code that went all over the place and jumped from here to there, what they called spaghetti code. You had principles, and Pascal was designed to teach these kind of principles where you had one way in, one way out of a function, structure that always went in certain directions and under certain kind of controls. Things they got rid of were global variables, got rid of go-to statements that could go off in some direction or another. You could always follow the logic flow. You go to object-oriented programming, suddenly that loosens up again. You go into an object, and sorry for those folks who aren't in this kind of code, but you go into an object and you've got all these attributes and they're global variables. And suddenly all the problems that people have with global variables come right back into the methods that you write into there. So it took me a while because I was pretty sold on structured programming. When I first realized that, I was like, I don't know whether I can use this stuff, but I consider it valuable now. I write a lot of stuff in object. Okay, I know we got to be over now, right? Somebody else is needing to talk. So thanks for listening. I don't know how to close this up now.
Thank you so much, Professor Gregory. I learned a lot.
Big thank you to
My class, you're going to hear a whole lot more of that.
sure. Big thank you to Professor Gregory. We really enjoyed your presentation, and we really enjoyed talking to you. For those who are still interested to pick at Professor Gregory's brain, he'll be here after this.
Yeah, no, I'm here for the airplane contest, and
Yeah.
I guess there's ice cream too later, right?
Yeah.
I'll just stay for that.
At 8.
So we'll have Professor Gregory here to talk to as a mentor, or just to talk to about a lot of these cool technology principles.
And then for those of you here, feel free to fill out the raffle. The password is Iliac. Yeah. So yeah, and we'll be having our Smash tournament right now. So I don't know if Jason and Jacob are coming in with the Switch, but yeah.
Good deal. Okay, so I've been writing code for a long time. And writing code can be very creative, intellectually challenging, and rewarding on many levels. It's like being paid very well for playing a high-level intellectual game. I think all of you here are on a very good path. And what you're doing today is probably the most important aspect of your education. You're learning how to problem solve, and you're learning how to learn. On the path you're embarking on, there will always be new things to learn. A key aspect of the learning process is research. I always tell younger developers that if you can Google on the right phrase, you can appear to be a genius. In your ACC video, I really like Jason Kim's comment about hitting a brick wall and keep trying. If you're persistent, you will eventually learn how to engage creative flow states. I'll close my presentation with some thoughts on creative flow states. In this presentation, we'll focus primarily on architecture for authentication, but along the way, we'll talk about organizational theory and why some of the leading technology companies in the world are now experiencing a spectacular failure. This doesn't work now. I can do page down maybe. Yeah.
Cool. Are you trying now?
There we go. Okay, in all the applications I've created, the authentication component has been problematic, from usernames and passwords to MFA to security keys to the FIDO architecture. About 3 years ago, I attended a FIDO conference here in Austin. Even though the conference was run by marketing people, not technical people, I had great hopes. After about 2 months of research and going through some very bad technical documentation, I came to the conclusion that the FIDO architecture was flawed. The essence of the FIDO architecture is that you first authenticate to a device through biometrics. The FIDO goal is to eliminate usernames and passwords, and then the private key on that device is used to authenticate to the application. This device-centric architecture means that you have to register each device before you can use it. I thought this was a very kludgy architecture that would never catch on. In their spec, they did mention roaming authenticators, where you could authenticate to your mobile phone, and the phone would communicate to the internet browser over web Bluetooth, a localized out-of-band confirmation. I actually thought that was a brilliant idea. This would solve the major problem in web authentication, ensure the user is on the right web page, chase.com, not chaz.com. But FIDO never really developed this idea. There was no reference implementation or code guidance. When I asked, the reply was, stay tuned, this is a work in progress. It was clear that FIDO was focused on biometrics and security keys. So I set out to create my own prototype. Along the way, the story of one engineer inspired me. Meet John Hubble. He figured out how to go to the moon, but few people were listening. These slides will be available on the website, and this link to the NPR article, it's a cool article worth reading. There are 3 competing strategies for going to the moon: direct ascent, one big rocket all the way; Earth orbit rendezvous, build a space station first; and lunar orbit rendezvous, 2 small spacecraft. All the top managers at NASA favored Earth orbit rendezvous, build the space station first. Groupthink developed, they became convinced that they were right. When you're around a lot of really smart people and everyone is saying the same thing, it is difficult not to go along with the group consensus. Hubble wrote a letter to the NASA administrators and he said, do we want to go to the moon or not? And through persistence and controversy, his plan for lunar orbit rendezvous eventually carried way. And there were bitter feelings. Von Braun really wanted Earth orbit rendezvous because he wanted a space station. But despite their differences, Hubble, who left the agency in '63, was invited to the Apollo 11 landing on June 20th, 1969. And von Braun turned to him and said, thank you, John, it is a good idea. Groupthink is a psychological phenomena that occurs within a group of people in which the desire for harmony or conformity in the group results in an irrational or dysfunctional decision-making outcome. Group members try to minimize conflicts and reach a consensus decision without critical evaluation of alternative viewpoints, by actively suppressing dissenting viewpoints and by isolating themselves from outside influences. Groupthink requires individuals to avoid raising controversial issues or alternative solutions, and there is a loss of individual creativity, uniqueness, and independent thinking. The dysfunctional group dynamics of the in-group produces an illusion of invulnerability, an inflated certainty that the right decision has been made. Thus, the in-group significantly overrates its own abilities in decision-making and significantly underrates the abilities of its opponents. As Hubble demonstrated, it's possible for one individual to break through groupthink. The FIDO Alliance was formed to solve the authentication problem. The alliance is primarily led by Google and Microsoft. Their goal of simpler, stronger authentication is a noble goal. However, Google, Microsoft, and the other leading technology companies of the FIDO Alliance are consumed by groupthink. And there's a lot of them. They have recruited just about everybody into their cult. And we'll see where this follows up in a little bit. They're desperate to justify their belief that passwords are the problem and that biometrics and security keys are the answer. They initially created a device-centric architecture. A user authenticates to the device, and then the private key in the device is used for authentication. Cybersecurity axiom. Everyone knows that usernames and passwords are a major problem. The Verizon data breach report, 61% of breaches involve credentials. For more than 10 years, the most common solution has been to send a sign-on token to a user's mobile device. However, the FBI has warned for more than 3 years that these multi-factor authentication schemes are subject to advanced attacks, especially when the tokens are sent through text messages. Roger Grimes has written a book, Hacking Multi-Authentication. If you think your authentication scheme is secure, check out this book or Google on MFA replay attack. Cybersecurity axiom. All current forms of multi-factor authentication can be hacked. On January 26, 2020 of this year, the White House OMB released a comprehensive memo that essentially deprecated all current approaches to MFA. The FIDO Alliance has been pushing their very kludgy passwordless architecture for the last 8 years. It was supposedly their answers to the problems of passwords and multi-factor authentication. On January 3rd, 2022 of this year, I wrote, the FIDO, in a paper that I published, the FIDO Alliance will most likely fail. The FIDO dependence on biometrics and security keys is impractical. There's no way for developers to code a universal solution. Their device-centric architecture is inelegant. Everything depends on the device and not the user. Their developer support is minimal. If you want an assessment of the current challenges facing FIDO implementation, watch a link to this webinar, Ask FIDO Anything, Developer Spotlight. It was broadcast on February 22nd of this year. It highlights the problems developers are having, and it shows how not ready for primetime FIDO is. This is a webinar of 3 leading developers from different companies that are implementing FIDO, and everyone called in and said, this is the problem. And I felt sorry for the guys in the webinar. On March 17th, the FIDO Alliance put out a press release and white paper, essentially admitting their failure and setting off on a new, very doubtful path. FIDO's new process will open a back door for evil corporations and evil governments. It will never be implemented. Seriously, any senior developer or architect who reads about the new FIDO process for trusting the operating system to transfer keys between systems will have an oh my God reaction. MFA is deprecated, FIDO is flawed. There is nothing right now for secure authentication. Something must come in to fill the void. An elegant open source system that has low user friction and is highly secure, only one attack vector will win the day. WebAuthn Plus is the answer. I know this sounds remarkable, but a tech startup in Austin has created a genuine breakthrough in authentication. This is a link to the full technical white paper. What's that?
We placed that technical white paper to Discord.
Thank you. This technology will play a significant role in winning the cybersecurity war. We're going to give this technology away for free, mostly. Free for open source on-prem. We'll maintain the rights for cloud-based services. If a bad actor can install malware on your system and either compromise your operating system or your browser, it's game over, you lost. We are not saying we can protect against malware or sophisticated DNS attacks. We are saying we can stop all phishing attempts and provide secure authentication with low user friction. We are saying that your credentials cannot be compromised, even if there is a complete breach of server data. The next statement is amazing. We can make simple passwords incredibly secure on trusted systems, a home computer or an office workstation. Even passwords like PW, ASD, 123, etc. The nirvana of simple, secure passwords will become a reality. Consumers want simple passwords. This is why simple passwords have stuck around for so long. This is a link to the FIDO specification. It's a W3C recommendation. Standards should be simple and clear. The W3C WebAuthn recommendation is convoluted and very complex. It's over 150 pages long and it reeks of artificial complexity. It's now in its 9th version since March of 2019, just 3 years ago. Anyone who has been in IT for any reasonable period of time will see the W3C WebAuthn recommendation as an opportunity for IT service providers to create complex systems and sell consulting services. When I contacted FIDO and asked them about their support for the development community, is there a clear step-by-step reference implementation for FIDO technologies? Their reply was polite and crystal clear. I hope you kindly understand that there are people who make a living from related consulting services, so the information in the public domain is somewhat limited. The WebAuthn document reads like the blueprint for a massive suspension bridge to be built across a narrow creek. The problem that needs to be solved for secure web authentication is actually very simple. Ensure the user is on the right web page, chase.com, not chaz.com. This would completely stop phishing scams. This could be accomplished by a simple change to the Web Bluetooth API. The complexity of FIDO's WebAuthn is completely unnecessary. Imagine a world where authentication is convenient, simple, and secure. A user goes to the web application sign-on page. They click the WebAuthn Plus button, and the browser communicates securely with the server over TLS and with the user's mobile device over a paired Web Bluetooth low-energy connection. Using Web Bluetooth to confirm the domain name in an out-of-band, no-internet process solves the fundamental problem of web authentication. The same values that are sent to the browser are sent to the user's smartphone over an encrypted Firebase channel with local confirmation over Web Bluetooth. The user verifies the authentication code and then touches the sign-on button on a smartphone. The sign-on web page is automatically transformed. The verification code is also sent to the mobile device. The simplicity of this authentication process is that the user goes to a web page, receives a notification on his smartphone, and simply touches the sign-on button. But users do not want to have to use their smartphone every time they sign on to a web application. You can establish a trusted system in WebAuthn Plus. When you sign on, you'll have a checkbox for establish this as a trusted system, and you can enter your own password and confirm that password. And again, the password could be 123 ASD, and I'll show you in just a second why that password will be incredibly secure on a trusted system. Everyone assumed that username and passwords had to be eliminated in order to solve the authentication problem. The paradox of WebAuthn Plus is that most users will be able to keep their usernames and passwords can become even simpler. Some technical details. The password for a trusted system can be incredibly simple because the password value that the user enters is combined with a UUID salt value that is stored on the system as a cookie. Hence, the system needs to be trusted and secure. If a bad actor can gain physical access to your system or install malware, they can read all the unencrypted data on your system. In Chrome, it's very easy to see the cookie values. This content right here is actually the UUID value that we use for the SJCL salt. On a system that has a secure operating system and a secure internet browser, only the website that placed the cookie or a user with physical access to the system can read the cookie. Some organizations may not want to take this risk and may disable trusted systems for WebAuthn Plus. The simple user password and UUID salt values are used to generate a cryptographic hash using the PBKDF2 function from the Stanford JavaScript cryptography library. So essentially, a simple password becomes this incredibly long hex string. This value is essentially a generated password and is sent to the server over encrypted HTTPS. The value is hashed once again on the server with the Argon2 ID hashing algorithm, the most secure hashing algorithm, and is stored on the server as a set of Argon2 ID parameters. So in your database on the server, I wish I had a pointer, the bottom value is the value that's stored. Whenever the user signs on, the hash values are recalculated and compared with the stored hash value. Without access to the user's physical system and knowledge of the user's password, it is impossible for a bad actor to sign on, even if there was a complete breach of the server data. The user can use the same simple password across multiple sites because each time it will be combined with a different salt value and will be stored on different servers as completely different hash values. I've been hacked before because I use the same complex password across multiple sites. Assuming your Windows system is secure and there's no malware on your smartphone that can read into another application memory space, TLS architecture for communication and strong cryptography make for an unhackable system, even if your phone is lost or stolen. It's not very difficult to create a cryptographically secure system. Public key cryptography, some basics, and I'm probably speaking down to this audience. The initial sign-on process for WebAuthn Plus uses public key cryptography. While the math of implementing a cryptographic system can be complex, the basic principles are very simple. There are two broad categories of encryption, symmetric and asymmetric. Symmetric encryption depends on a single key that needs to be shared among the people who encrypt and decrypt messages. Symmetric encryption can be very secure if the key is strong and protected. The bureaucratic nightmare of securing and administering secret keys inspired the creation of asymmetric encryption, which is usually referred to as public key cryptography. Here's everything you need to know about the magic of public key cryptography. There are two keys, a public key, which everyone has access to, and a private key, which you must keep private for the system to be secure. If a bad actor gets access to your private key, it's game over, you lost. A message that's encrypted with your public key can only be decrypted with your private key. So people can send you encrypted messages. When you send a message, if you sign it with your private key, that signature can be confirmed with your public key. That is the essence of public key cryptography. Securing data on your smartphone. In the WebAuthn Plus process, the credential provider sends messages from the application server to your smartphone through an encrypted Firebase channel. This message can only be decrypted with your private key, which is stored securely on your smartphone. What do you mean, stored securely on your smartphone? Is that a joke? Is this guy an idiot? We all know from the Apple versus FBI encounter that anything on your smartphone can be decrypted by anyone with marginal computer skills. It's incredibly easy to do. Well, it's not easy to do if the encryption process is done in a sensible manner. Send the following architectural overview to your friends at Apple. When a user downloads and activates the WebAuthn Plus mobile app from the Apple App Store or from the Google Play Store, in the installation process, the mobile app generates a 4096-bit public-private key pair in less than 10 seconds. It's a very large key pair. It's double the recommendation by RSA Laboratories. The public key is uploaded to the mobile app provider's data structures. The private key never leaves your smartphone. The private key is stored on your smartphone in an encrypted state. If you've ever dealt with Linux systems and certs, you know that you create the cert on the Linux system and it never leaves that system. In order to maintain a high level of security, an AES 256-bit symmetric key is also created when the WebAuthn Plus mobile app is installed. This 256-bit key is used to encrypt data on the smartphone, encrypt and decrypt data on the smartphone. This key is not stored on the smartphone, it is stored on the server in an encrypted state. When the WebAuthn Plus mobile app is installed, the user creates a password for the app. This password is used to create an obfuscated identifier. We'll come back to that in just a little bit, which is associated with the user's 256-bit key. Both are stored in the mobile app provider's data structures. From then on, whenever a user initializes the mobile app, the password is entered, the identifier is recreated, sent to the server, and the 256-bit AES key is returned. After a configurable number of bad attempts, the server locks out and the mobile app, you require the assistance of your banker or corporate security. So this prevents a brute force attack. It's impossible for an external bad actor to attack WebAuthn Plus through a brute force attack. There's no way to get the 256-bit key, even if your smartphone is lost or stolen. It's important to associate this key not with the user, but with an obfuscated identifier, because a bad actor within the organization might be able to associate the key to the user. So you want to do something that's not associated to the user. The only way to secure data on a smartphone is to encrypt the data with a key that is stored off the device, delete the key from the smartphone when it's not needed, and load the key in a secure process when it is needed. The WebAuthn process takes just a few seconds and is within the boundaries of being user-friendly. And all of our source code is available, and the license is going to be such that anybody who creates a mobile app can use this architecture to secure data on their smartphone. So if your smartphone is lost or stolen, they can't get to the data. At this point in the game, there's still one more security challenge to be addressed. What if the government gets involved? If a government agency ordered a service provider to provide all the keys in all the obfuscated identifiers, and they also had the user's smartphone, they might have enough information to break the system. The attempt to break the system would fail if the user has chosen a complex password for the WebAuthn Plus mobile app. Wait a minute, the weak link of the system depends on a user password. That can't be good. There's a significant difference between a web application, which is a distributed application running on multiple systems and in multiple browser applications, and a mobile app running on a single system that you control. And don't forget that the mobile app will lock out after a configurable number of failed attempts. The only way a password that you enter into the WebAuthn Plus mobile app can be intercepted is if there is malware running on your phone, game over, you lost, or if a bad actor looks over your shoulder, steals your password, and then steals your smartphone and defeats the fingerprint reader or other security before you can report your smartphone lost or stolen. Then the bad actor can access your account. This is the only real threat vector against WebAuthn Plus. Why don't we just use the security key within the trusted platform module provided by the phone manufacturers? This is what FIDO does. It must be a good idea. In fact, it's a really bad idea. We have more information on this in our white paper. But for now, on March 15, 2022, Bruce Schneider, and that should be a name. If you guys are going to get into IT, it's a name you guys should all be familiar with. He writes this monthly newsletter called Cryptogram. He's one of the world leading experts in cryptography. And in that newsletter, they showed that the Samsung TPM module had a flaw that was exploitable to the point where you could compromise FIDO2 credentials in the Google Secure Key import. This report and many others raise a very serious question. How many flaws have been deliberately engineered into systems as backdoors based on the collusion between amoralistic corporations and evil governments? Cybersecurity axiom: it's a bad idea to create backdoors. The biggest risk is that they'll be discovered by bad actors and do real damage before they can be closed. Some more technical details. I might skip through some of this. Okay, so the obfuscated identifier is, there are two inputs into this algorithm, the password itself and the iteration count. The more complex the password, the higher the iteration count, the higher the computational cost for anyone trying to crack the secret key. The password is combined with the UUID salt value to guarantee uniqueness. When a user enters his password, it goes through the process and grabs the AES key from the server. The reference implementation uses an iteration count of 262,000. And that's about a 2.5-second penalty on a good smartphone within the limits of a bad user experience. If a government agency had ordered a service provider to decrypt all the data on a user's smartphone, and they had all the information that they needed, all the keys, all the obfuscated identifiers, if the user chooses a mobile app password that is ridiculously easy to guess, PW123, then the quality of the algorithm and the iteration count do not make a difference. The system is very vulnerable. So in this use case, this is a use case where simple passwords fail. On most mobile app keyboards, there are 82 characters to choose from, 26 lowercase, uppercase, numeric, and symbols. If a user creates a password with 12 characters, there are 82 to the 12th power possible permutations to consider when cracking the secret key. That's 92 sextillion and change. If you randomly go through half the possibilities, you have about a 64% chance of hitting the right password. How long would that take if each guess took 1 second to compute and you had an array of 1 million computers? Well, the calculation comes out to 1.465 billion years. And in cryptography, the key is to use algorithms that require a significant time penalty to defeat. Assume that a user chooses an 8-character password. The number of possibilities goes to still a pretty high number, and the calculation goes to 32.4 years. Not great, but maybe good enough. Assuming that you're trying to protect some system like your phone with a 4-digit numerical PIN, that's only 10,000 possible combinations. That can be cracked in seconds. Okay, the Bluetooth allows a localized out-of-band connection. And because it's localized, you can architect it so people can't intervene and intercept the signal. In the current prototype, the information is transferred to the JavaScript methods in the Web Bluetooth API. A GATT server is created on the phone, the server broadcasts, and then the web application writes to that server with the domain name to confirm that the user's on the right web page. So because we use the current JavaScript API, the system right now is vulnerable. What we need instead is an application context. So we need a method in JavaScript that will write this value from the browser application context or from the operating system. And I've downloaded the Chrome community source code. It's a very challenging problem to go through that code and get the right changes done. So if anybody here is a really, really good C++ program and you would like a hacking job, send me an email and I will utilize your services. It's just I haven't had time to do it. I haven't left my day job. This is still very much a garage level startup. And that's it. A simple change in one method in the Web Bluetooth API is all that is needed to solve the authentication problem. That's almost it. There's some other things. If you've ever implemented Web Bluetooth in a browser, there's some very, very inelegant pairing process that comes up that could be made much more secure and much more efficient through session-specific pairing. And that's also in our white paper. Okay, at that point, what time is it?
It's 4:33.
4:33. So we still have about 20 more minutes. Let me go on and I'll talk about some issues of identity and credential management that this architecture will make possible. Okay, Okay, in the late 70s and early 80s, computer names were maintained using these handcrafted host.txt files. And as networks became more interconnected, this process became unmanageable. Everybody knew that something needed to be done. And when the DNS system came about, everyone saw it as the obvious solution. And similarly, when the solution to authentication problem emerges, everyone will say, of course, this is how it had to be. The basic question is, how can trust be established in the digital age? If you and I have never met and I come to your website or place of business, how can you be confident that my digital credential is valid? WebAuthn Plus answers this basic question regarding trust. The answer is a cryptographically secure digital credential on a user's smartphone. If a credential is provisioned to your smartphone in a valid institutional process, the receiver can be highly certain that the credential and the user are valid. Why? Because the user has a secure private key and the credential was associated to that key in a valid institutional process. Because the receiver can cryptographically verify that you are the person to whom the credential was issued, it truly does not matter who you are. What matters are institutional validations and the ability to represent those validations with cryptographically secure digital credentials. What's a valid institutional process? It's the identity proofing process. It can be anything the institution defines and controls, from the very simple to the highly secure. In the most basic use case, the credential provider of a web application simply wants to secure the account to the user who created the account. Identity attributes do not need to be verified. Valid authentication from the user who created the account simply needs to be secured and repeatable. This can be accomplished through simple verification through an email. The process for creating digital credentials can also take place in a highly secure process. Banks have a very elaborate know your customer protocol that you have to jump through all kinds of hoops to establish banking accounts or apply for a mortgage or do other transactions with banks. This secure identity proofing represents a high level institutional validation and can be a very complex process. Key thing about this is that there's no master identity proofing process that one organization or government controls. The identity proofing takes place by the institution when the credential is issued. Organizations can maintain complete control of their authentication. When you don't need any third-party validation, when it's just like within ACC or within a corporation or within a government agency, you can operate this system as an insulated microcosm. And for third parties, there needs to be some check for valid keys of the people who issued the credentials. Surprisingly, there is no need to store user credentials or identity data in any type of worldwide data structure. The integrity of a digital credential is determined by the hash codes and signatures that are contained within the credential itself. Okay, we'll skip some of this. Trust authority, binding. Okay, who are you? Under WebAuthn Plus, the concept of identity has fundamentally changed. Who are you? You're the entity that has been issued a cryptographically secure digital credential. If I'm accepting your financial credential, do I really care about your date of birth or your mother's maiden name? No, I just care that the credential is valid. The traditional view of identity is that you're a collection of identity attributes: username, first name, last name, date of birth, credit history, address, and then you establish an association to these attributes through the three factors of authentication: something you know, something you have, something you are. In the new age of identity, your smartphone is a security device for securing your private key and your association to your digital credentials. Identity attributes do not matter. Okay. Okay, and with that, I think there's been a lot of information so far, and I think I'll pause it here for questions. There's more information in the white paper and in this slide deck, which is also on the website, about the difference between. Oh, one thing. Let's do this real quick.
You have another mic out there.
Okay, this is something that's going to be incredibly cool. The ability to sign documents with the private key on your smartphone will make it possible to create cryptographically secure private distributed ledgers for all types of business and financial processes. This has nothing to do with the Bitcoin hype. This has everything to do with secure authentication, transforming business process management, and creating practical AI systems. This process will be the foundation of a world technology platform that will lead to the creation of the Internet of Value. If you're not familiar with what the Internet of Value is, Google on it. It's a fascinating concept, and essentially it says that we're going to make financial transactions flow as securely and as easily as information. And these distributed ledgers will be in a very simple JSON format. They'll have the user's digital credential in it. A hash code will be created of the information and signed with the user's private key. And also, these distributed ledgers will become the record format for cybersecurity audits. And audits are ill-defined right now by most organizations. You end up searching through a lot of database records and logs, and those are essentially text records that could be easily hacked. All right. Okay, and this is not theoretical. We have a functioning prototype and everything works. You can install the app and then go to our test page and test it, except not for a few days, because I went to Costco last weekend and got a new workstation, and I'm still in the process of configuring it. So it'll be a couple days before that's ready to go. Okay, and this is, I think, a key aspect of our system. A system is secure if the plans for the system are public and the bad actors can still not break in. Our source code is available for download. Some worthwhile goals we're working on: secure authentication, zero trust architectures. Just real quick, the essence of what a zero trust architecture is that most organizations right now have what are called a castle and moat architecture for cybersecurity. They have this really intense perimeter that defends against intrusions into the castle. But once you're in, there's a lot of things that are unprotected. Zero trust architectures essentially say that you're going to authenticate to every system that's within the organization. And secure authentication is a key factor in establishing these architectures. The license isn't defined yet. We're going to give most of this away for free. Okay, a question. Since before your sun burned hot in space and before your race was born, I have awaited a question. Does anybody know where that quote came from? Anybody? The guy with the beard has got to know. City on the Edge of Forever. It's a classic Star Trek episode. It's the Guardian of Forever. And before we go to questions real quick, as I said in my intro, one of the reasons I really like writing code and I like doing what I do is because I really think it is an artistic endeavor. It's a very intensely creative process. And the idea of, and this book really describes creative flow states. And there's another book that he references simply called Flow, written by this psychologist from the University of Chicago named Mikhail Csikszentmihalyi. And it's considered the classic work on flow states. And essentially a flow state is that you're doing something that is right on the edge of your ability. It intrigues you. It captivates you. You lose track of time. You get involved in this just creative immersion, and 6 hours will go by and it seems like no time has passed at all. And it really is an artistic endeavor. And people who write code for complex systems at a very high level, you can get into these creative flow states, and it really is a creative endeavor. So if you're going to pursue this as a career, after your studies here, I would really suggest that you use that as a goal. And you can write me, email me. I'll try to answer any questions that come up, and I'll keep you posted on what we're doing. I'm going to try to recruit some of you early on to be part of this process. We haven't, right now I'm in the process of getting this technology vetted by some members of International Systems Security Association. And once I have about 12 people on the technical advisor committee, I wanted to get like 6 students too. And then we'll go talk to the venture capitalists or start publicizing it more. I haven't even gone to publicize it, or this is actually the first public presentation of this technology. So if this really is the answer to authentication, you guys will be able to tell your kids that, I was at the very first presentation of WebAuthn Plus. But any questions?
And Mike's email and his website will be posted in the Discord. If you have any questions later on, or if you want to reach out, maybe you have some sort of change or augmentation that you think is even simpler than this, that you can recommend by any chance.
And like I said, I'm really, and I went on, what's that, Upwork? I'm really looking for, I'm primarily a Java programmer. I jumped into this technology in the early 90s, HTML, Java, JavaScript. I started out with Java at the very beginning of the technology. So that's my strength. And I have gone in and looked at the Chromium C++ code, and I think I could do it, but it would take me weeks of hacking around. A really good C++ programmer could probably do in a few days. So if that's your skill set, let me know, and we will find some way to compensate you appropriately.
Any questions or anything? I'll come around with a mic. Yeah.
So I bet I'm one of the slower people in the room here, so I apologize for testing my understanding. But I think the thesis you're getting at here is that the individual's mobile device is the basis for trust. As long as they're in control of an uncompromised device,
yep,
the Bluetooth connection between whatever it is they're doing on their computer, laptop, whatever, communicates with their phone to establish their identity, and then goes and
over a localized connection, because your private key is on the phone. A session UID is sent both to the browser and to your phone. That session UID is signed by your private key on the phone and transmitted back to the server. And if the key is verified, then you're in.
Okay. So my next question is directed towards a further test of my understanding, and it is specifically, you said that you could prevent a user from going to an unanticipated website, or I guess like a phishing scam.
Right.
What I'm unsure as to how
Okay.
the authentication works.
What happens is that, and this is why we need a connection we need a method from the application, from the operating system context, or the browser context. Right now, you can communicate from a web browser to a GATT server running on your phone over a web Bluetooth call through the JavaScript API. And in the prototype, that's what we're doing. But what I need the C++ programmer for is to transfer that method into the system level code of the browser. And then that way it becomes a case that people couldn't create a hacked website. They would have to create a hacked browser application or hacked operating system in order to do that transfer illicitly.
Yeah, I think basically to answer your question, kind of is like typical phishing scams. I think Mike explained to me one time is that the way they work is that say like you're on eBay, right? Someone sends you a link to buy something on eBay. Instead, it's like eBay spelled with like an an A or something, some misspelling. So you sign in and you put in your credit card information, or you sign into your eBay account, which has your credit card stored on that account through that website. But that's like a different website, right? So it takes your information, relays it to a different computer with a different browser, right? And that's how they get into your account. What WebAuthn Plus does is that it works, it establishes a connection from your phone to the browser that you're logging in on, which means that someone on a different browser or a different computer can't log into your account.
Or
That's
a different website.
Yeah.
Yeah.
Is that correct?
That's pretty close.
Yeah. Are there any other questions? Oh, sure. So someone in the Zoom chat asks, so would this make it possible to, as an example, sign mortgage, title paperwork from the comfort of one's home? Sounds
Yes.
fascinating.
Yeah, it really would. And if your bank had issued you a credential to your phone, and like I said, the key thing is that you need to keep your phone secure. And if nobody looks over your shoulder, seals your mobile app password, and then seals your phone, if they do that, they can get into your account. But if you keep your phone secure, report it lost, or as long as your phone's secure, they would be able to do that. And the cool thing is, and it's in the slides, I didn't get to it for time, that also there's going to be digital DNA. Like all the different biometrics are flawed, especially facial recognition for racial stereotypes, and it doesn't work well. But digital DNA is a biometric that is absolutely secure. There's more details in the white paper and in the slide presentation. But what they do is they take a small, and the technology is there. There are companies that are doing this right now. They take it as small, and it's not a DNA profile like for 23andMe. It's just a small sample of your DNA that establishes uniqueness. You would go in, get that digital DNA, that would be part of your phone, and that would establish your legal identity. Now, there's a difference between application identity and legal identity, and this is a part that we skipped over on the slides too. Application identity is like Netflix. You go to Netflix, they really don't care who you are. They just care that you're going to send them money every month, and you're the only guy who can watch their videos. So they really don't care about what your absolute legal identity is. But certain other people, like banks, government agencies, they absolutely do care about legal identity. And I really want to do business with a bank where only somebody with my digital DNA can go in and utilize and get access to my account.
So the digital DNA, would that be almost like a thumbprint, but
no, it's they take a DNA profile, like swabbing your they like swabbing your mouth and getting the actual DNA, and they take a partial DNA profile. There's no revealing information about your full genetic profile to protect privacy reasons. Okay. So some of the companies that are doing this, they've thought it through, and there's a way to get enough of your unique DNA that provides a clear identifier, but doesn't reveal, like, if you have Hodgkin's disease or something like that. So it doesn't give your full genetic profile. But that I'm convinced that's going to happen. That's absolutely going to happen.
So they would just upload your DNA code into a database, basically.
You go into your bank or into the passport agency, or you know when it'll happen? It will happen immediately when you're born, and it will be encoded into your digital birth certificate. And then from then on, when you get a driver's license, they'll do the same thing again. They'll match it. It'll be, okay, this is legally who this person is. And you get a passport, they'll do the same thing. So digital DNA it's the future.
So you've created this technology, and my question is, will it rely on apps and websites implementing it for it to actually take off? Or is this something that can be used with a website that does not specifically implement your code?
What we'll have is some it'll be both. Okay, the source code's out there and available. So some in most organizations are going to want to go in and go through everything. I mean, when it comes to authentication, especially for like a financial institution, they'll want to know every line of code. This is another reason why the latest variation from FIDO is never going to happen, because everything's obfuscated in their code. All right, you can't look at what they're really doing. But we'll have source code available. They could implement it themselves, and we'll have a cloud-based service that you can just drop in some JavaScript into your application, and it will run on our service, and we'll do everything for you. That's by giving it away, we'll vet the technology through a lot of different organizations, and then I think we'll make a lot of money through the cloud-based service.
So you do have to like opt in to use it, but you're making it really, really easy to use.
Yeah, you will have to. Yeah, it's like anything, any authentication process. You have to. And I'll tell you, having implemented a lot of these things, like even RSA Secure ID, where you get the code on your phone. I don't know if you guys use that here. What do you guys use for MFA here at ACC? Is there a second factor?
I think it's text message.
Text message. Okay, that's really bad. But some of them are better. Like RSA Secure ID is pretty good. That's not too hard to implement. They give you enough libraries to do it, and that's the one I utilize in my real world job.
Thank you.
But even that, like Malik said, can be hacked. Oh, I know what I want to say. For a future hackathon, I think a really cool topic would be to create a hack of MFA authentication, like Google Authenticator. Create a hack of Google Authenticator and show how easy that is to do. Bring up a Google Authenticator, fake Google Authenticator site, have people go into another site and grab their credentials. And yeah, you have to watch the legal liability on that. Probably Google's like might get angry.
Yeah, it'd be pretty ridiculous if you did it in under 24 hours.
No. I think you guys, I'll come and help you. I've looked at it. I know how it's done, and there's so, and that's the other thing too about sleep and being a developer. Google on, how much time do we have? I don't want to ramble on, but Google on this phrase BBC second sleep. Okay, you'll get a really cool article from the BBC that talks about how sleep patterns developed in human cultures. And there's this idea that we were really evolved for this 2-phase sleep-wake cycle. Like to go to bed, like I usually go to bed around 10 o'clock, sleep for about 4 hours, wake up at 2, work till about 6, and then go to sleep for 3 more hours, and then wake up and work again. And during that nighttime period, where like it's really quiet and nobody's around, I can lose track of time, and there's no pressures and no IMs, and that's some of my most productive time. But BBC Second Sleep is a really cool, insightful website.
We have one more question.
Actually, one comment and one question. Probably an age thing, and it's not my future, but the idea of a DNA future, digital DNA is not my idea of what I would appreciate as a future. The idea that we'll all have those, that everybody's DNA will somehow be encoded in some type of database. I don't know how comfortable y'all are, but it's yours.
I know.
But
I know. And on our website, and I think in the white paper, I talk about that. And you can be, it's coming. And you talk about biometrics and tracking people. China is off the charts on this stuff. Just literally ridiculously authoritarian, off the charts. So it's not the technology that's the problem. It is the legal system of the society that you are in is the problem. And as long as we handle that and don't let big corporations take this over, because they're going to love it too. I mean,
well, my comment on that is, how well's that worked so far?
Well, Europe just came through with this right to be forgotten, where you can go to Google and say, hey, get rid of all my stuff, all of it. Okay. And we should do the same thing in the United States. We should absolutely do the same thing. The power of big corporations on our private data is something that's gotten ridiculous. In your generation, it's just one of the many things that the baby boomers screwed up that you're going to have to fix.
Good luck. But
luck.
my question was, are you familiar with the work of Oleg Kormodz? I can't pronounce his name. Komogordzov at Texas State University.
No.
On a biometric, what he does, what they've done there, what he did really, they have a eye motion tracking. They have a moving dot that your eye will follow, and they will build out of that sequence of motions. They have built a model of the muscle movement of your eyes. You would basically build a map of what muscle eye movements you moved, particular eye movements there that would follow that track for any given person. I think more important part of that model, actually, rather than just the cybersecurity, it's not really the muscle movements. They have in that model a model of the neurosignals that were sent to those muscles to make that pattern. So what you have there, almost the complexity of a DNA profile in the brain patterns that you followed to follow that particular track that you watched for,
Right.
I don't know how long ago.
And once they integrate the chips directly into our skull, that problem will just be.
Well, that's, I mean, my impression of it, when I saw that, I thought, cryptography is the smallest part of what you've just done here. If you can build a model of connections, a model of those kind of brain activities.
Yeah.
But that's an example of a biometric, I think, that isn't one of the ones we think of, at least so far, as being that. I mean, the whole idea of being able to take a contact lens and fool a retinal scan and things like
Right.
that.
Or my favorite is the gummy bear hack for fingerprint readers. Are you guys familiar with that? Google on that. It's entertaining.
Anyway, I just they're doing, for any of you who I've talked about, they're interested in transferring to Texas State. That's somebody you might want to talk to if you go down there. He's again, I cannot pronounce his last name. Komogortsov. Oleg is the first name that you might recognize. Anyway.
Professor there?
Yeah.
All right. Is there another question? Oh, down there.
Several times I've heard you say that it is the cell phone that has to hold the information securely. How does that work?
Okay, the way it works is that when you install the WebAuthn mobile app, you generate two keys. You create a asymmetric public-private key pair, and you generate a symmetric AES 256-bit key. Okay, that AES 256-bit key is used to encrypt and decrypt the private key that stays on your cell phone. That 256-bit key is encrypted with a password-based key derivation algorithm key that comes from the password that you enter into the cell phone. Okay. It's encrypted in that state and sent off to the server to be associated with your obfuscated identifier. Then when you log back into the WebAuthn Plus mobile app, the process is regenerated. It goes back, gets it, comes back down, decrypts it, and it's used to decrypt the information on your cell phone. And like I said, the source code's available, source code's there. And it does depend on you creating a fairly complex password for your WebAuthn mobile app. Because, like I said, simple passwords, you can brute force them if somebody got your phone and they had access to the server data. So what I'm worried about most is governments, okay, trying to decrypt it and get access to your accounts. But
yeah, I worry about governments too, but
yeah. So, but if you use a very complex password for your mobile app, it's a really cryptographically secure system.
are you using any of the available technology features of contemporary processors to store data on the phone?
No, and like I said, on most devices and most phones, there's something called the Trusted Platform Module. Okay, it's where private keys are stored by the manufacturer in the chip manufacturer. Okay. And I'd like to think that you could trust them. But in the white paper, there's a link that says, hey, click here and you can see why these guys should not be trusted. So that was the goal. Okay, that was the goal, to get everything apart and independent from the device. Okay, and just to use pure algorithms and pure code that resides on the phone that anybody could look at. There's no magic black boxes. Okay, it's everything is right there for anybody to evaluate and to look at. And yeah, we'll see.
Would you come and find me later and have a chat with me? I work for ARM.
I will, but I want to find Jason Kim too first. Is he in the room still?
Went outside to go
Pick up dinner. What's for dinner? All right. Okay, so okay. Well, darn. I wish I would have known that, because my Star Trek quote, I was going to say, if you don't know the answer to this, you don't get dinner. And also too, real quick, I assume everybody here is really into, any other questions real quick before I ramble on?
So I use a hardware security key for the stuff that I care about the most.
Yubico.
Yeah, exactly. So, you know, as cumbersome as it is, it calculates a one-time password. It's protected biometrically and by a complex password that I have memorized. So assuming I'm okay with the cumbersomeness and assuming my device isn't compromised, how is that less secure than?
It's not. I say in my white paper that and Yubico was one of the main drivers of the FIDO Alliance. Okay, they were in there early on, and I talked to this lady from Yubico at the conference. They were like, "Oh yeah, this is how." And I said, "Well, what if I write a web application? Do I have to distribute your security key to everybody who wants to utilize my application?" And she goes, "Well, we're more for like internal. Like Facebook uses Yubico security keys for everybody in the organization." But the thing is, I mean, how many developers leave their workstation and leave their key plugged into their workstation? You know, or somebody steals their key. But the Yubico architecture, it's a pretty highly secure architecture, because again, it's off the system. It's something you trust and you know. So it's not, and I think it's going to stay around for specialty applications. Okay, like if you're incredibly wealthy and you need to access, you know, a highly trusted number account that you have set up in Switzerland because, you know, that's what wealthy people do. The Yubico security key is probably going to be something that you'd want to use. It's not. I think it's secure. I think it's secure technology, but it's, like you said, it's cumbersome.
So it's making it the experience more user-friendly. And also the way I have it set up, I'm assuming it's still susceptible to phishing. Like if I enter that one-time password into a website that's not what I think it is.
I think in the FIDO application of the implementation of the Yubico security key and the sites that implement that, there's the same check that goes to the key for the domain name that I utilize through web Bluetooth on the phone. Okay, and truthfully, when I went to this conference in Austin with the FIDO Alliance, and I went back and started reading the documentation, there is something in the documentation about roaming authenticators that they just never implemented. And so they were so focused on biometrics and security keys and completely getting rid of passwords. But I really think for me, and like I must have on my home computer, on my home workstation, I must have like 50 tabs open at any time, at least, maybe closer to 100. And logging into a lot of different websites, I don't want to have to pull out my phone to do that every time. If I could just go ASD bang, because I trust, and I've got really good home security cameras at home. So I don't think anybody's getting in and messing with my computer. But yeah, but you're right. Yubico is not a bad technology.
Any other questions real quick? Final thoughts? Nothing? I guess that might be it. Do you have any final
I have one closing thought, because I assume everybody here is really interested in technology. And growing up in the 1960s, I'm a huge space guy. Okay. I'm very impressed with what Elon Musk is doing right now. And his plan, it's going to be interesting to see, because his plan to go back to the moon is to use the Starship, which is like the biggest rocket ever built, to go direct descent to the moon. He's infatuated with this technology of landing and being able to take off again. Okay. A full rocket. So that's his plan, and the Starship is going to launch this summer down on in Boca Chica, which is really close to South Padre Island. Yeah. So, and the only risk is that when they announce the date, none of them have ever taken off on the date that they announce. So you'd have to have like a week's window probably to go down and see it. But it's going to be, even on the news, it's going to be something very, very cool to see when that takes off. So. As a final thought, what you guys are doing, I think, is really, really cool. I wish you all the best of luck. I truly love working with younger developers and on cool projects and getting things done. And like I said, I think I've recruited Malik, but we'll see. And I'm going to try to recruit some other people to work on this project. It's going to be an amazing amount of fun. And the interesting part of this too is going to be how it all evolves. And I haven't gone to any venture capitalists. I think one of the things that Mark Zuckerberg did brilliantly well is he let venture capitalists chase him. So what we want to do is get a bunch of people from high-level security people to validate the technology, get some press, and then have some people approach us and see what they want to do. And really, we're not looking to raise that much money, because once we have the system set up and running and people are utilizing it, it should throw off a lot of cash. So it should be a pretty fun gig to be involved with.
Sure. Thank you so much, Mike. That's WebAuthn Plus, ladies and gentlemen.
Yeah, and it's thank you. Thanks. And trustnexus.io will get you there. And any input you have or any recommendations or anything you find, and like I said, the source code, you can get the source code now, but the full test application sometime over the weekend, I'll get that back up and running. But there's a lot of information on our website, and go through our white paper and see what you think, and just see if it makes sense to you, and whether or not you see any holes in it. But I don't think there are any. I will buy someone their favorite beverage if they can find a serious hole in the architecture.
Thank you so much, Mike.
You're welcome. Thank you.
WebAuthn Plus's first public presentation at ACC's first hackathon. So it's definitely two firsts.
I want you all to go home and tell your moms tonight that this guy gave a presentation where he said that people from Google and Microsoft are delusional. and he might be right.
Yeah, but I mean, this concludes this workshop. Right now we have around a crazy amount of sandwiches out back. So yeah, feel free to take 2 or 1 home. So yeah, we have a lot. And yeah, free to ask Mike any more questions. And we'll be having our typing competition in about 10-15 minutes. So yeah, just feel free to go outside, grab something, take a break from your coding, and yeah, come back and finish out the night.
Yeah.
And then,
awesome. Thank you, Nate. Hello, everyone. Hope everyone's having a great time at RiverHacks. I'll be discussing intro to app development. My name is Camden. I've been a software engineer for the past 10 years. I started at age 11 making a Minecraft server plugins, and I moved from Java to Kotlin and eventually to Golang, which is what I do for my job. Today, I'll be presenting with Matthew. Matthew, would you like to introduce yourself?
Sure. I'm a programmer. I've been programming for 13-ish years now. Mainly in Java, but I now work in Golang and PHP at McGraw-Hill.
Yeah, and I work with them. So whenever I make an app, what I want to figure out is the technology I want to use. So there's a lot of different technology we can use, such as React and Native. So say you're a web developer and you like HTML, CSS, JavaScript, all that. You could use React Native in order to stay in that realm and be familiar with what you're working in. And compile for mobile apps, web, whatever. Another we can use is a thing called Develop Native. And this is another ideal thing for web developers, try and make apps for mobile. Also, I'd like to mention that in the Discord on the app Intro to App Development channel, I posted the Zoom link. Feel free to ask questions there. I'll be answering it at the end. So say you want to make a game, what I'd personally use is either Unity or Unreal Engine. These are both ways you can design a game and run it on mobile, desktop, whatever. So if you want to make it an Apple app, I would use Swift. Which is a language made by Apple specifically for app development. And in order to make an Apple app, you have to pay $100 a month or a year for a development license. The language I personally like using for making apps is a language called Kotlin. It's basically very similar to Java. It takes all the features of Java and removes the boilerplate. So here an example of a hello world type of thing, and you can just see that's just straight to the point. It's also very good for multi-platform development, and we have Kotlin Compose. And in Kotlin Compose, we can support all these different types of platforms. You can support web, mobile, and desktop. Is there anything you would like to add, Matthew, to that?
If I remember correctly, Compose only works for Java, correct?
No. So Jetpack Compose works in Kotlin, and you can make Android apps. You can use the same code to make Apple apps. That's what makes Kotlin a very powerful language, is that you can just write it once and use it on multiple platforms. So as a student, what I'd personally first look into is a thing called a GitHub Student Pack. So all you have to do is sign up here, and you use your student email. And once you sign up, you get all this stuff for free. You get tons and tons of stuff that you can just use for your day-to-day development. And I recommend that every single student does that. So in case you don't know what GitHub is, it's essentially a way that developers store code. So I have all these types of projects on my own repo. And whenever you apply to a job, you want to send your GitHub and your resume. And you can show off what work you have done. And you can see if I click on one of these, you can go through all the code. You have a little README saying what the project is. And it's also a good way to collaborate. So say I want to make changes, I post over here, and then say another developer wants to make changes, he also posts and pulls from here. That way we all are working on the same project at the same time. So if you want to get started with programming apps, I think the first thing I would install is a thing called JetBrains Toolbox. And essentially what this does is allows you to download every single app you need to do development in almost any language. So you have IntelliJ for Java, Kotlin, Groovy, you have WebStorm for web development, you have Writer for C#, you have AppCode for Swift, and PyCharm for Python, and so on. So JetBrains makes some really good tools that every developer should use. GitHub Student Pack gives free licenses to all their software, as long as you're a student. So you can get all the premium features of these softwares for free. So whenever I decide to make an app, I use a tool called Figma. It's actually like a Google Doc type of software where you can collaborate and do designs. So say me and Matthew want to design an app together. We can both mess with this at the same exact time and bounce through ideas together. So here's an example of me making Meal Slice, which is a meal prepping app I'm working on. It's a very basic design at the moment, but it's very powerful what you can do with this tool. See, I can modify it on the fly. It tries to align it for me. if I wanted to, I can say exactly how this app functions, and then I can present it. So we'll see if this works. So you can see over here, this is how it looks on mobile. Unfortunately, I need to mess with that, as you can see. And then you can see how this will look frame by frame. So using tools like Figma is very powerful. I use it for almost every project I do. I also use this in tandem with Google Docs to document how I'm gonna make it an app. Whenever I'm working on a big project, it's very important to plan out every single aspect of it. Is there anything you'd like to add to that, Matthew?
One of the ways we have planned things out is by creating something called sprints. It's a way of organizing developmental steps into smaller, concise pieces.
Yeah. So what we try to do is we have like 2-week sprints, right? So we try to get as much code done within those sprints in order to keep on pace. So an example of this, let's see if I can find it. I might not be able to find it actually. Actually, no, was it misslist? Yeah. Sorry about the cat. Let's see.
Isn't it under issues?
Issues, yeah. So we have all these issues, right? We want to make a server for it and all that, and that goes under sprints. And essentially what we do is we assign it to each other. So this is Matthew, this is me. And we decide like how we're going to split up the tasks for the app, and we can like do it all on GitHub. So we all work on it in tandem at the same time. So one of the other cool parts about Figma is that you can export images. So say I want to export just this frame right here. I wanted to export it. You can export it as a PNG, SVG, JPEG, PDF, you name it. And it's a very powerful tool, as I was saying earlier. So yeah, so on that note, I'd say start installing JetBrains Toolbox if you want to follow along, and install Android Studio. I'll give you guys 5 minutes to do that. In the meantime, let's see if you have any questions. Yeah, you want to install the Toolbox rather than Android Studio directly, because Toolbox will help you update your apps as well. If you only install Android Studio, it will make you like reinstall the whole thing. Toolbox will help you manage that in a lot smoother manner. When you get Android Studio all set up, you want to like install the Android SDK. You want to set up a Darkula theme, all that. You can pretty much go to default settings. Also, in the meantime, what we're going to be using is Jetpack Compose for this application. So if you want to read over any of that, just go to the site. I'll send it in the channel. I'm gonna have Nate tell me when you guys are ready to continue. All right, I guess got word that we're ready to continue. So the next step we want to do is I'll switch my screens over. Let me get this all set up. All right, so once you have Android Studio on this page, you just want to go ahead and click New Project. And then it's going to ask you what type of project you want. In this case, we want empty compose activity. And I'm going to name this application RiverHacks. You can see it automatically names your package, but I'm going to make it my domain backwards. And then the minimum SDK, let's go 21, that's good enough for us. And click finish. And you reshare my screen.
It is standard practice in Java and other Java-like applications to use a domain name backwards as the package name.
Yes, and so now it's loading on the bottom right, you can see. This will probably take you guys a little bit for it to load fully. But I've loaded projects before, so it should be a little bit faster. In the meantime, we can go over like what this does. So over here, this is when onCreate is called. So when this application is first started, it's going to set the content to be the greeting message, as you can see over here. And you can see it's greeting Android because Compose is a multi-platform application or library. And in this case, it's specifically for Android we're greeting, but we can also greet other operating systems different ways. So this is a very basic app. It should just show hello Android, and we'll see if I can get this to run. Oh, some people got lost. Are you able to help them, Nate, or do you need me to go over something again? Yeah, I can show you guys again. So I'll go ahead and create a new project so you guys can follow along. Let me reshare. Awesome. So the first thing you want to do is click New Project. The next thing you want to do is click Empty Compose Activity. And then over here, you want to put the name of your application. So in my case, it was RiverHacks. And then you want to click Finish. I've already created this project, so I'm not going to click Finish in this case. I'll wait for Nate to tell me that everything's good now before continuing. Oh, so if you have any questions, Zoom call, just put in the chat. All right, I just got word, everything's good. So I'll reload RiverHacks. I have to reshare my screen. Awesome. So now it sets you up with a very basic setup. As I was mentioning before, we have a greeting to Android because this is an Android app in this case, but it could also be a Mac app. It could be whatever app. It could be a web app. Compose doesn't know, but it can support all of those. In this case, it's an Android app. So we're going to try to run this and hopefully it works first try. So you can see on the bottom right, it's building. And maybe we can even follow along. So you can see it's like starting to Gradle Damien. It's doing all the tasks that Gradle has. And Gradle is just a build tool. So this tells it how to build the app in this case. And you can see the configuration for that inside the build Gradle file. And you only understand this right now. This is something you learn in your own time. It's not very important in this case. If you ever want to like add a library, you'll do it in the dependency section though. And let's go into presentation mode. Actually, I don't think I'll show you the emulator in that case, so let's wait. So you can see like it emulates all of Android. This is literally like an exact replica of Android. And you can see it's running my app on it. And one of the really cool parts about this is that if you already have a set value, you can actually change it in real time. So you can see it's changing the value on the screen as I type it. So that makes it very easy to refine your code in real time, make sure it looks good to your user, and all that. So what we have is just a text right now. This is a very basic setup, but we also have like rows and columns that we can use. So what we can do is have a row for text and repeat this 100 times. If you want to repeat the row 100 times, not the text. Essentially what this is a for loop that goes from 0 to 100, or actually 99. And it should hopefully it's not. Okay. So I think we need a column first. See if that changes it. There we go. So you can see it has all these hello Androids now. And making it scrollable should be as easy as modifier.vertical scrollable if I can remember right. I think it's mutable scroll state. Remember scroll state. Okay. So see if that works. Awesome. So now we have an app where you can scroll through a bunch of hello androids. I'm not sure how useful that is, but you can see it's like very dynamic. So when I'm scrolling, it tries to even like pad it differently. So you see us trying to space it out more. It's very reactive by default. So that's one of the nice things about Compose is that it really has a lot of attention to detail. And it'll allow for a lot of stuff by default. So let's say you're done with this app, okay? Let's just say that you're done, you want to like post this project on Git. So how would I go about that? So
Ken, you want to explain what Kotlin is?
Yeah. So Kotlin is a programming language very similar to Java. Basically, I'll show you guys how powerful Kotlin is. Let me show you. So this is what my friends, let's see if I can find one of his code samples for this. So we have a JUser here. So say you're writing in Java, right? You have this whole class called JUser, and you can see that it's like 150 lines, right? Now, the crazy part is that this exact class is one line in Kotlin. So this line right here is equal to all 143 lines of Java code. And the really nice part about Kotlin is that it's fully interoperable with Java. So you can write your code half in Java, half in Kotlin, and you can transition as slow as you want. This makes it very easy for companies to move over with very low overhead.
Essentially, Kotlin just removes a lot of boilerplate from Java.
Yeah, and it does a little bit more than that. It also has multi-platform features. So you can like write an app once and you can like support Android, iOS, server-side, front-end, you name it. You can do it for everything just by writing it like once. And here's a bunch of like examples they have. They have a really good like tutorial and stuff. And you want to like use IntelliJ most times for this. And so Android has first class support for Kotlin. So like the main language for Android right now is Kotlin. So it's very worth learning. Is there anything you'd like to add to that, Matthew?
If Kotlin or Java isn't your thing, Android also does have an NDK for native development kit, which allows you to code in C or C++ or any other native language that can compile to binary.
Yeah, so like one of the things I was looking into is like making apps in Golang. But the thing is that Golang isn't really very multi-platform in this case. Like a lot of the libraries aren't really made to be like iOS and Android supported. Meanwhile, Kotlin's main focus was that. So there are some cases where I'd rather use Kotlin than Golang, but Golang is kind of my go-to for a lot of projects nowadays. And I'll show you guys a website for Golang. This is very good for like near native performance as well. Awesome. So back to what we're doing. So we're going to make a new GitHub project. So if you want to follow along, what you're going to need to do is sign up on GitHub. And I'll give you guys 2 minutes to do that. The site is github.com.
You also need to install a Git client. If you're on Windows, anyways, most distros have Git already installed.
Doesn't Android Studio and IntelliJ like already have a good client built in, or just like downloads it for you?
It does.
Okay, so in this case, it'll be fine.
If you use the terminal inside the Android Studios, it's fine. Or if you use the GUI inside Android Studios.
Awesome. Also, if you want to install the Git client, like Matthew was saying, you just go to git-scm.com. I'll send that in the chat. And you just click download for Windows over here and just set that up. Okay, so we're at this window. Now we're going to click plus, new repository. Now we're going to make a repository name called RiverHacks app. And then if you want to, you can put a description. I'll put RiverHacks with a bunch of hello androids. You can go ahead and add a README file. And for the .gignore, you want to set that to colon. License, you can read over this in your free time. I personally like using the MIT license. And then I'm going to create the repository.
I personally like the GPL license.
Yeah, so basically what those licenses do is just like how restrictive your code is. So like you can say whether or not companies can use your code, whether like if they use your code, they have to publicly disclose it, and so on. How much liability you have and everything. So when you click over here, you want to go to HTTPS, and then you want to click copy.
It should be noted you're using HTTPS because SSH requires you to create and put a key on your GitHub.
Yeah, I'll use a SSH for mine, but you guys use HTTPS. Awesome. And then once that's done, I'm going to go back into my Android Studio. And we're going to click on terminal on the bottom. Now over here, what we want to do is see the interior desktop. And type git clone, and I'll zoom in for you guys, or I can't maybe. I guess I can't zoom in here. Oh well. But it's git clone, and you paste the URL.
Looks like your key's not set up.
I guess my key's not set up, so I'll just use HTTPS link.
Also, do git -- version real quick. Yeah, I thought so. That's a manually installed version.
Yeah.
I don't think that's going to work for them. You'd have to use the one built into the Android Studios client if you don't install one.
Okay, so if you want to follow along with this, you have to install the Git client. All right. And then what you want to do is git clone the URL while you're in your desktop. Once you do that, on your desktop, there'll be a folder called RiverHacks app, or whatever your repo name is. and you'll have a folder. Let's see if I can share the screen. Yeah. So you have a folder that looks like this. Essentially what you want is these 4 files, and you'll just drag it into your current project directory. So I'll show you that too. So you can see this is the current directory for the project. I got here by right-clicking on the project name in Android Studio and clicking Open and Explore. Now I'm just going to copy the files from the Git clone over to this folder. And once that's done, we have these 4 folder files added to this directory. Now that we have that, we go back to Android Studio, and you'll notice that a lot of things are red. So the stuff that's red right now isn't getting pushed to Git. So you only want to add what you want to get. So you right click on it and you go to Git, add. And now that will be pushed to Git next time you make a commit. So I'm just going to go ahead and add all these files. And I also add the whole source directory. Awesome. So now that we have that, all you need to do is git commit, and you'll see this is a list of all the files that will be uploaded to GitHub. And then you type in the message for your commit, which will be, in this case, init, which means it's initial. And we'll just go ahead and push that. And in the meantime, I'll show you what it looks like on GitHub. Which is right here. So you can see it's only these 2 files right now. But once I commit and push, if it goes through, it's loading. It wants me to log into GitHub to do this. So, might not be able to show this. All right, I don't have my computer set up enough for this, but when you do commit and push, all your files will show up over here, and then you'll be able to pull the changes into Android Studio if you ever do so. So yeah, I mean, yeah.
Go to Android Studio real quick.
Okay. What's up?
No, whenever you run git push, can't you log in?
I tried it. It didn't work. This has been a known issue of Android Studio. You have to use token for it.
Oh, then just grab a token. That's very easy to grab.
Yeah, okay, let me grab a token real quick.
You might not want to be sharing the screen with the token, by the way.
I know. Does this hide it? No, it doesn't. All right, let me here.
Essentially, copy to your clipboard. Oh, yeah, that works.
All right, 1 second. Let me get this for you guys. All right, so we got it. Matthew saved the day. Now let's go back over here. Okay, so now if I refresh, you can see all the code has been pushed. This is my README file right here, and you can just see that this is what everyone will see. If I want to, I can change it. So this is basically like what everyone will see when you first load your project.
README is in a markdown format. The extension is .md. It's essentially a text file with special grammar.
Yeah, so you can see right here, I have a hashtag, which just means header in this case. And the more hashtags you have, the smaller the header. So we'll just like add meow to this. And then we'll commit and push. So now I just commit and pushed from GitHub itself. So this is like an example of like, say someone else changes your project. That's what it'll be like. Now, if I go back to Android Studio, you'll notice that if I open the README file, it is not changed yet. In order for me to pull these changes, I had to click over here. I had to click OK. And now you can see these changes have been pushed forward to my code. So that's a very basic description of how app development usually goes. I hope I explained it very well. If you guys have any questions, feel free to message me. We have the rest of the time for any questions that I can answer now. If Nate wants to go
I will
around.
say
and
the
ask.
advantage of using GitHub is not only centralized storage of your code, other people can contribute. If you make it public, you could get the community involved. Overall, and GitHub's not the only place. As you saw, we used a command called git. That is the actual program being used, and a lot of services have support for Git code.
It's also good to mention that GitHub is like the first thing that people look at when you apply to a job. So if you apply to a job, you definitely want to have your GitHub all nice and set up. I suggest us having LinkedIn set up so you can get recruiters going. And this is a good way to find a career. Cool or complicated in compose. Matthew, do you have Meal Slice open?
Let me see if I can get Meal Slice open real quick.
Yeah, I can share Matthew's screen for the. I don't think I have it set up on this computer though. Yeah. I can break on it.
I mean, honestly, that'd probably be faster, especially if you haven't pushed your changes recently.
Yeah, let me go ahead and try that. Just give me 1 second. I'll reshare when I get that going. Okay. Hopefully it doesn't take too long to load it.
Okay, mine's loaded up.
If it doesn't load in the next 2 minutes, I'll just share your screen.
I mean, I have it loaded in preview. Did you want me to try and get the emulator working?
I think it'll be fine. I just need to reverse load.
Okay.
In the meantime, Nate, just see if anyone has any questions. I'd love to answer them.
Oh, it looks like I can't compile it. Something's wrong.
One of your changes broke it.
I haven't changed anything. Invalid source release 16. Are you using source release 16 in here?
Yeah. Are you using JVK 17?
Yes.
What's Kotlin? I already explained Kotlin. Is there something more you want me to dive into about Kotlin?
Also, it's with a K, not a C. Just
Yeah.
Let you know.
Like that. I don't know that one, Steve Jobs. I don't know that one.
Why is our JVM target only 1.8?
Not sure.
I bumped it up to 16. I'm also bumping up our target SDK version 31 since 30 and below are deprecated as of 2022.
Nice. So, sorry, it's taking me a long time to load this project. Let me know if you got loaded, Matthew, because I'm going to issue yours.
Well, I still got to get my JDK fixed. I guess I could use the built-in one. Give me a second to set that up.
Unfortunately, Gradle does take a little bit to set up the first time, but whenever you run it again, it's a lot faster because it uses a lot of cache.
Essentially, what's happened is it's downloading all the dependencies and also compiling some code.
In the meantime, I guess we can go over some of the code for it then. So let's see what we got. So what I did is I organized the stuff into different pages. So like here's a progress bar for one of the pages, here's an input box for one of the pages, and here's a setup page, which is very flexible, and I can make it ask any question from the user. As I was showing in the Figma, this is the backend code for that. And here's the welcome page. And this wasn't just a me project. This is something I worked on with Matthew. I worked on with Brendan. So multiple people worked on together. Let me think, William. Let's see. I'm not sure if I fully understand your question, but so you have like a private repo, right? At the end of the day, the repos contains code. So if you can get all that code and push it to a public repo, I mean, it's not recommended because it's private for a reason, but you can do that. But if you want to copy our commit history, Matthew, do you know a way to do that?
Yes, essentially, Git allows you to create whatever history you want. Technically, I can create a commit from 1998 before Git was even committed or was even made. Essentially, what you'll do is you just change the head and its origin to a different repository, and then you'll force push, which allows you to rewrite the entire history.
Oh, sorry, William. I misunderstood your question, I think. So if it's currently in a private repo, you can go to the settings for that repo and you can make it public. So let me show you how to do that.
And depending on which website you use, there's also a way to make it unlisted where it's link only.
Yeah, so you see over here, MailSlice is currently private, right? I don't want that code to be shared to anyone. So we go to settings and we can just change visibility over here and you can change it to be public. And then your potential employers can see it. Hopefully that helps. I guess I can also advertise something. Let's see. Hey Matthew, do you remember the name of that resume builder we used?
Oh, no, I do not.
Here, let me see if I can find it. I found it. So there is one thing I use whenever I make a resume. It's called job scan. So this will help you make a resume and like scan it. So like sometimes some websites will like automatically scan for like buzzwords and keywords from your resume. And this essentially does the same thing, except it like shows you how to optimize your resume for that. They also have a resume builder, and it helps you build a simple resume, which you can then put into Google Docs, Word, or whatever, and you can modify it to your liking. It's a very good starting point for resume, and I recommend it. Also, it seems the project has loaded, so let's see if I can actually run it, or we're gonna have some issues. And I'll send a link to that resume builder in the group. If you guys want any links, also just let me know. And I guess we'll end off on this app, so hopefully it works.
I did figure out the issue. If you're
You did
pulling
figure it
from
out?
master, it might appear. And if it does, I now have a solution.
I do know that I built this app on the beta version of Android Studio, which I am using now, so I guess it won't be a problem.
No, well, I'm also in the beta. We're synced up, Rover.
Yeah. Do you have the project in an emulator right now?
I do not have it in the emulator right now.
Can you try loading it?
Okay, give me a second. I haven't even started the emulator first run.
Yeah, I ran into the same issue you ran into.
Yeah, so go to the build.gradle.kts, change the Java version from 16 to 11.
Okay. Let me see, 1611.
I managed to get it by you when I was upgrading the Gradle files. Yeah, build works now once that's done.
Hopefully it does, because I'm not sure if I have JDK11 installed right now.
Well, you don't need JDK 11 for compatibility targets.
Okay.
You just need a version 11 or greater.
For some reason it's not letting me run it now though. I
What do
might
you mean it's not
restart
letting you
Android
run it?
Studio.
It looks like it's still running.
No, it's in like the top right here. Oh, there we go. All right. Okay, so we got the emulator loading. Awesome, let's go. So this is the app. I need to see, we can click register, we can type in my name. Click next, the budget, how many people, and so on, right? And you can see this is basically like the Figma app, except it's actually functional. Yeah, and then that's all I have to show you guys. So I hope you guys had a great time in this intro to programming. And thank you guys for participating.
Yeah, thanks so much, Camden, for speaking. Yeah, we really appreciate it. And Camden will also be in the Discord. So if you want him to answer any more questions, as long as it's not about Kotlin, yeah, just message him there.
What's called?
When I was here and I saw the last guy talking, he mentioned GitHub. So I was like, oh yeah, Trufflehog. So that's why I put that one up there. Trufflehog it searches GitHub because developers are lazy or they're new and they put passwords and their Git history, and somebody will go behind them and say, oh no, you shouldn't have done that, and they'll take out the secret and they'll whatever, right? But that thing is that Git stores all your commits. So whether or not you went in there and you threw that password and took it out, it's still in part of your history. So it's still going to be there. So give Triple Hog a shot, not on anything that you're not authorized to do. Hopefully everybody knows none of this stuff, nothing you do outside of what you're authorized to do. All right, cool. I was hoping to see more people in person because I do better with faces, but is everybody familiar with VMware and VMware Fusion, the different products? Yes, yes, yes. Yeah. Yep. Cool. Chat folk, I can't see head nods. Do they have their cameras on? Should I be having their cameras up?
No. They should, just tell them to type something.
All right, Freddie Hidalgo and Levin Millahan spoke for everybody when they said yeah. So we're good. All right. So we have I'm using VMware Fusion right now for Mac. I choose to use VMware Fusion over VirtualBox. A lot of people love VirtualBox. If you've heard of it, it's free. I don't like it because I run into a god awful amount of network issues. There's some funky network stuff that I'll be trying, and VirtualBox for whatever reason just it breaks on me. But the same VM works just fine in VMware. That's my preference. Doesn't have to be yours. The purpose of what I have in my terminal is to show you all that when you're running security, when you're doing things, you don't need the fancy tools that everybody's saying you need to have. Nmap is quick. Everybody's familiar with Nmap? No. Nope. Okay, perfect. Thank you. All right, Nmap. We'll do that real quick then. So Nmap is a tool used to scan networks. So you can scan a /24, /16. Everybody's familiar with CIDRs.
Zero cyber.
Okay. No worries. So we'll do /24. Like that's when you look at your IP address, you have 192.168.1.1. Well, when you do /24, that goes 192.168.1.1 through 254. So you have ostensibly 253, 54 hosts that you can scan on any network. Well, actually, you have more than that. You have 255.254.254.254. Those are all the hosts that you can scan, or you can make life. I'm getting too complicated. My bad, dude. Nmap. All right. Nmap scans systems for you. It scans for vulnerabilities. It scans for open ports. It's a great tool. But not every system you work on is going to have it. Not every system that you get on is going to be able to have it.
Is it something you download?
Yeah. So Linux comes built in with a number of different tools, Nmap not being one of them. There's another tool called MassScan. Do you want me to put this like on the screen, the tool names, or do you want me to put it in the chat? I can put it in the chat, right?
Yeah.
Okay. All right. Perfect. Good. Because I'll miss a lot. So MassScan is faster than Nmap. Don't worry about these tools. That's not the idea of what I'm trying to go after. I'm just letting you know there's multiple options for you to accomplish a goal. Information security is a curiosity field. It's a large field with a lot of different possibilities. You could like getting access to websites. He could like reverse engineering binaries. You could like social engineering people. All three of those are different aspects or different facets of cybersecurity, and all three are very important. So what I wanted to do today is just show you on the command line certain ways to accomplish a task that you'll see when you go through your tutorials. Will always tell you, use Nmap to do this, use MassScan to do this, or you do this that way. And it's not the only way. There's a saying, are you guys familiar with offensive security? No? Yes? Somewhat? All right, cool. And by the way, thank you 5 for at least being here, because now I can see faces. Yeah, dude, it happens. It happens. That was me just making fun. All right, so offensive security has a certification called the OSCP. At one point in time, it was considered the godsend of certifications. It's
ComTI's Security Plus.
much better than CompTIA. Much better, much harder.
What's the best security certification? What's like trained in-
Starting from the ground up, Security Plus, Network Plus, A Plus, things like that. The CompTIA certs I consider to be useless, but they're that was a crap way of me explaining it. The CompTIA certs are great for beginners. They're great for you guys. They're great for anybody just wanting to get in the field. When I say I consider them useless, it's just like when I have somebody my age touting their A Plus or Security Plus certificate, that tells me they haven't done much outside of that. Cybersecurity is a curiosity field, which is where I was going with earlier. It's a curiosity field, right? So you have to be curious, inherently curious about how something is happening. How does Nmap do what what it does, right? You guys are familiar with the ping utility, correct? Yeah. All right, perfect. So my IP address is 168.250.137, right? So if I ping 250.1, God, I forget sometimes. I'm using my Mac. I'm lazy. My Mac was lighter than my actual PC, so that's why I grabbed that. Yeah, you don't want to break inside. So if I ping 138, right? I got nothing back. To me, that tells me that host is down, right? Nmap will go through and just boom, boom, knock it all out. And it does great. But what's happening underneath the hood? What's going on? There's a lot of specific things and weird things that are happening that you don't need to worry about. But in essence, you can accomplish something very similar when you do something like this from the command line. So of course, right now, all I'm doing is on the keyboard, Control-Shift-C, Control-Shift-V to copy in and out of the terminal. So I have this long command in here, right? And all this command is really doing is it's saying declare a variable called IP. All right. That variable is going to be assigned to each one of these numbers 1 through 10, excuse me, 1 through 10. 10 times? Yeah. So it's iterating over it 10 times. So IP, the word IP will be 1, then 2, then 3, and so on. Yeah, that's exactly what it is. It's a for loop in bash. So it's saying for each IP, I want you to do ping -C, which is the number of times I'm waiting, number of response I wanted, right? So you're doing ping -C 1 time. That's all I care about. And then we're going to do 192.168.250 because that's my address, right? So I do that. Are you all familiar with the pipe command? Yes? Yes. I think that's a yes. Kind of quasi soda. Yeah, CSIPT? SIPT? What? What's SIPT? The person put that in the chat. I don't know, dude. I'm sorry. Anyway, so the pipe command, that's saying take everything on the left, put it into the right, put the output of the left into the right. So what I'm doing is I'm saying ping this address, take the results and put it into grep for me. Grep is looking at bytes from, because when you get a response, it'll say blah bytes, 64 bytes from blah, right? So grep is saying ignore all the other ones, just grab the ones that give you a response. Then we pipe it in, again, taking the output. So now we have the IP that's going in a sequence, or we have the numbers 1, 2, 3, 4 through 10, right? Take that number, throw it into the address, and I want you to ping it. When you ping it, I want you to throw it into grep, the result of ping into grep, and I want grep. Yes, sir. I'm pinging whatever is in the range of 192, 168, 250, 1 through 10.
Let's say I have a device here.
Mm-hmm.
It's not connected to the device.
1 second, since you're asking from the back end, should I repeat the question or can they hear him?
We should probably. Repeat it, it's fine. Yeah.
All right, cool. The question that was asked was, when I'm pinging something, correct me if I'm wrong. When I'm pinging something, am I pinging, if I have a device connected on the network, right? And it has an IP, you're asking if I'm pinging it? Okay. Okay, so it's got a different, okay. If the question is, if he's got a device here that is not connected to this network, but it does have an IP. So it's like tethered to your phone, hardwired, but it's not connected to the wireless network. You're asking if I can ping it. Technically, yes, but not from the network that I'm connected on. Does that make sense? So that gets into routing, and I can get overly complicated with routing because it depends. So have you ever been somewhere where you have a network A, network B, and network C? And sometimes you've noticed that A and B can talk to C, but they're two different address ranges. Have you ever seen that? Maybe not, most likely not. I can't see why you would, but that's called NATing. That's you're adding routes to your router to tell it to go there. So technically yes, but I don't want to get too complicated. Sound good? I'm sorry, dude. Yes. It depends on the network setup. It's a lot easier if I'm on your network for me to ping you. I mean, it's not different. Anyway, sorry. I know that's a crappy answer, and I know that you probably don't feel fulfilled with it, and I'm sorry. That's the best one I can give you without going down some god awful rabbit hole, which is how my brain works. I'm sorry. All right. Yeah. Oh, I thought that's what you were trying to say. The SysP. SysP is decent if you want to be a manager. All right, so we got IP going into ping with the IP address, and the variable IP is getting thrown in there for the last octet. Taking that output, which will be either what you saw here where it says from 192.168.250.137 unreachable, right? You'll either get that output or you'll get 64 bytes or something like that from this address. So I'm taking the results of that ping, throwing it into grep, having grep say, only show me the ones that say bytes from, because that's showing me the ones that have replied. Then I take that those grep results, because it's gonna give me the whole line. It's not gonna just say bytes from. It's gonna, oh, my bad. Are you guys familiar with grep? Yes.
It's like kind of grabbing certain parts of like from the response function.
Grep is a utility that you can use to search for strings inside files or strings inside data. Linux, one thing I was taught, God, years ago, was Linux treats everything like a file. So even your disks, it's dev SDH, it looks like a file. Linux treats everything like a file. Grep will go through all of that. And if you let it, it'll search for the strings. Do you want me to wait?
No, I'll be listening from outside. I just gotta grab water.
Hakuna Matata. All right. Hopefully I don't say that too much. That'll get annoying. My bad. All right. So it's
Start out. What's like your background to this?
dude, my bad. All right. I'm all, nah, man.
You can like continue to explain it after. I don't want to like cut off your thought flow.
Nah, it's already been paused. We're good. The question was about my background, and that's on me, everybody. And by the way, I say guys a lot, and I know that I'm not supposed to, or at least I've been told I'm not supposed to. So if that offends somebody in the chat or in here, please let me know. I'm not here to offend anyone. All right, my background. I spent about 10 years in the intelligence community, running both offensive technical operations against people and against our nation's adversaries. I'm sorry?
What's the intelligence
community? Oh, sorry. So the question was, what's the intelligence community? The intelligence community is formed up of a number of organizations: NSA, CIA, DNI. I think there's Yeah, I think that's it. And you'll have different organizations that'll be working with them. So the FBI will have a detail person at the NSA and the CIA, DNI. So you have different government organizations that are detailed to them. Me personally, I spent my whole career working at the CIA as a government contractor. It was fun. Did a lot of really cool things. Half my career was doing offensive technical operations. The other half was doing network defense. So running pen tests on internal devices on the network and identifying issues where they may reside. And then I moved away from that. Honestly, I got tired of it. I was driving like 2 hours a day each direction to get to work. And it's just, got boring. So, yes, sir.
Were you not able to like do it virtually? Like,
Oh, Lord, no.
you wouldn't let me?
No. No, when you're working in the IC or working as a government contractor, the work for home option with that level of clearance is non-existent. It's just something that all of us used to dream about and talk about how nice it would be, but it's just not possible. So, for people in the chat, he asked if we were allowed to work from home, right? That was your question? All right, cool. That was my answer. Do I prefer red team or blue team? I'm not a fan of just solely one or the other. Red teams do cooler things, but they also are subjected to whatever parameters are provided to them. So people will come up to them and say, we need you to test this thing. And this is the only thing that you can test. This is the only thing that you can touch. But as a pen tester, you're, like I said earlier, you have to have innate curiosity. So you want to branch out. Or maybe you know that if you could branch out, you could get back into this box because it's all about the weakest link, right? So I'm not allowed to go after this server, but the only way to get to this server that I found so far is to go with that one because of the connection between these two. But I can't. Well, how many times have you known bad guys to say, oh, that's my bad. I can't make that system go down. You know, it makes no sense. So to me, red teams really aren't able to do the jobs that they need to do. Blue team, I like it. I like the aspect of being able to have open box testing. I had a different definition of blue team than what the private sector considers blue team. So my blue team experience, traditional blue team experience, I'd have to say would be less than what it really is. It's hard to explain because we define blue team differently in the way we did things. From what I understand, the private sector blue team, they work on the defense to capture or to catch the red teamers. That wasn't my objective on the blue team. My blue team objective was to attack machines and do open box testing, and in some cases, closed box testing. Open box testing is when you know about the network setup, you know about the system, you know everything you need to know. You have vulnerability scans, you have the whole 9 yards. Now all you got to do is just use it. Closed box testing is when you don't do the exact opposite. You don't know squat, nothing. So now I am doing something a lot less what people would consider sexier. My kid actually told me he wishes I still worked where I worked. He liked telling people that he can't tell them, although technically he wasn't supposed to tell them that. Anyway, what I do now is I work for a company called Devo. I couldn't ask for a better company. They treat their employees. I have unlimited leave and I work from home. I mean, you can't ask for a better deal. A great company. I create signatures for attacks to put into a SIM. Do you guys know what a SIM is? SIEM? Huh? Mm-mm. No, it's SIEM. Doo-doo-doo. Oh, and also I suffer from shiny object syndrome. So you'll see me going like this a lot. And when I say I suffer from, it's just a joke. It means I get distracted easily. SIM, it's a security incident and event management system. Check me on that one, since you're right up here with me. Security incident and event management system, I believe, is what it stands for.
Security information.
I always screw up the I. Security information and event management. Do you mind throwing a link to it, to the definition in the chat for me? Thank you. Bless you. All right. So, so I make signatures for a SIM. A SIM monitors logs. Everything has a log. There's one thing I learned when I was in college. It's called the Lockhart principle. I don't know if you guys have learned it or not, or if you ever will. The Lockhart principle is you leave something behind on anything that you touch, whether it be an impression, whether it be a part of you or something. Same thing's true with computers. You leave a log, you leave a trace, some kind of something that you've been there. If you're really good, then maybe not, but no, you're not. You leave something. I'm going to just stick with that. So with my responsibilities at Devo, I am supposed to grab those logs, the various logs that are generated. I set up a lab environment. I exploit a system and I take those logs and throw them up into Devo for Devo to create alerts, and then I create the alerts. All right. So y'all want me to start over on this command thing?
Oh, I wanted to ask, like, even earlier than that, like, what do you, to get into cybersecurity, because most people here are probably like within their first 2 years of studies in community college, or are planning to probably transfer over or maybe get an associate's degree. What would you recommend to sort of break into cybersecurity? If you had to start all the way over?
You're doing it.
Just get is it computer science degree, or is it a specific certificate or a specific program?
No, it's curiosity, and it's not letting it die. People value certificates. A lot of organizations will value certificates.
That's what I hear. So like if so, like, for example, like web development, it's pretty easy to get a like I hear the way to like sort of break in is through like projects. But what types of projects would you recommend for cybersecurity? Because for web development, that's pretty easy. You can make a web app.
I get you. I'm getting there. I got you. I got you. I'm picking up what you're setting down.
Yeah.
It's like I said, it's a curiosity field, right? So how did I break into it? I kind of just forced my way into it. It's hard to explain. I had, so one of the big issues with government contracting was all you needed was a clearance and a pulse to get a job. And they kind of weren't wrong, because clearances, the level of clearance that we had was so high that, it lowered the hiring pool. So I'm kind of a unique situation. But for you guys, I highly recommend, yes, Hack the Box Score. Thank you. I was going to mention that too. There are so many ways that you guys can link up with people. Discord, getting on the various channels, InfoSec jobs, getting your name out there, tweeting stuff. Don't think that somebody else has already tweeted this, or don't think that somebody else has already written about this, or nobody gives a shit what I have to say. Because if you knock yourself out of the mix, then you took yourself out of the competition, right? So tweeting, GitHub, taking your time. Cybersecurity, the field, we rely unbelievably heavily on open source projects. Recon NG is an open source project done by Landmaster. He created this tool written in Python, did it for free, and it's used everywhere. In fact, Offensive Security uses it in their teaching materials. Right? This is because a guy saw a need, figured a way to resolve that need, and still managed to keep his job, keep his family, and stay up late while he was working on this need. It's curiosity. The more you get your name out there, with talks. I mean, honestly, that's part of the reason why I'm here, is because I spent what, 10 or 12 years hiding. And so nobody knows who I am. Nobody knows anything that I've done. And so when I saw the opportunity like this come up, I was like, yeah, because I love talking about this stuff with people. So talking about it, getting people to setting this stuff up, putting this stuff on your resume. I'm sure it's not what you want to hear, because I'm not given like a checkbox, because there is none, as far as I'm concerned. And I'm also not the single voice of cybersecurity, right? There are plenty of people that are going to disagree with everything I say. You'll find them, and when you do, latch on to them. All right, latch on to them, latch on to me. I don't care. The more opinions you get, of course, there's always too many opinions, but the more opinions you get, the more information you have at your disposal. So get your name out there. Learn Python, learn Go, learn Rust, learn VMware, learn how to accomplish the tasks. All right, y'all just saw a thing on web design, right? If I'm not mistaken, I saw one of your presentations with web design. Yeah. All right. Stand up a web server. It's free. It's easy. Heroku. No, don't use them. It's because it's not gonna do what I want it to do when I'm telling you guys to try to do. Yeah. Yeah. So like there's a Metasploit. There's, what is it? It's Metasploitable. My man, this is my boy right here. Can you find a link to Metasploitable for me and throw that in the chat? There's a Metasploitable. It's a virtual machine you can download. You spin it up, and it walks you through how to hack it. You can't ask for a better learning opportunity, right? Hack the Box. There is a guy that does videos for Hack the Box, IPSec. If you can put that in the chat too, ippsec.rocks. Who has a school? Oh, Hack the Box does. Yeah. Yes, they do. But I'm not talking about pay for stuff. Everything that I'm talking about is free. You all are students. Some of you probably live with your folks. Some of you probably live on your own and are doing your best to get by in both situations. The last thing you want to do is spend $300 for a burp license, or spend $300 for Hack the Box stuff. You don't want to do that. Hell, I'm out of college and I still don't want to do it. So all the same things that I'm talking about are free. And what else? Yeah, that's honestly all I can think of, man. It's just getting your name out there the best you can. Learn stuff. I have a lot of patience and a lot of tolerance for people wanting to come and asking questions on how to do things. But me personally, that patience and tolerance runs low if I'm seeing that person come to me all the time. All right, without any plans, anything. I tell it to my kids, I told it to coworkers. If you come up to me, have 3 solutions or 3 possibilities that you've explored that haven't worked for whatever reason, or just 3 options that you think are viable. Don't come to me saying, hey, the web server, I'm not able to access it. Okay. Do you want a cookie? So go back there and try to figure it out. It's all about your level of curiosity. I'm a firm believer in that. There is no one cert, in my opinion, or one degree that you can get that will make you an expert in the field. I mean, you asked me out there, am I the cybersecurity expert? My response was no. I don't consider myself an expert. The word expert scares me. I know some experts, and they are, wow, right? I don't consider myself that level.
It's crazy for you to say after working like having 10 years of experience in
Well, see, that's the problem. That's why I don't like using it. I don't like saying it. The only reason I answered it is the only reason I told you all that it was CIA was because someone had asked about what the IC stood for. I don't want me to get some kind of street cred or automatic, wow, this guy knows what the hell he's talking about because he worked at the CIA. Because I'm telling you, there's some idiots that work there. Total morons. They are people just like you. All right. just like me. So just because I worked there, just because you guys watched a lot of movies with Jason Bourne in it, doesn't mean that stuff is true and doesn't mean that's what those people are. Sound good? All right. I purposely stay away from saying parts of my background because I don't want to, you get a certain level where people are like, oh my God, he knows what he's talking about. That's awesome. I don't deserve that, in my opinion. Take me for who I am and then make your decision after that. So did I answer all the questions? Perfect. You're good?
Yeah.
All right, my man. All right. I'm going to start on this command thing again, just from scratch. And don't worry about interrupting. If you want to interrupt, you have a question, cool. I peek over at this chat window frequently because I don't want to screw anybody. If I miss something and you guys are watching chat, let me know, please. All right. So on this command, we're doing the for loop, right? We're assigning IP a variable of 1 through 10. And we're telling it ping-c1, which means do it just one time, one response. We're piping the result from that into grep. Grep is a search utility used to find keywords or various other things, right? So I'm going to grep it, take the results from grep, which are only going to give me the hosts that are up, pipe that into cut. What cut does is cut takes standard input. You guys know what standard input is? Cool. I'm only seeing one person literally nod their head. So that means to me that nobody knows what standard input is. Perfect. Standard input is your keyboard. When you're typing something in, that's input. Standard output is the results from you hitting enter. And you see the output of a command, right? So all these pipes are treating these results as standard input. So it's no different than if I were to type in ping-c 192.168.250.1, and then I copy those results, I paste them into a file, and I say grep for bytes from, and then I take that. This is no different than that. Make sense? So that's what standard input is. So I'm grepping for bytes from, taking that's output from there, throwing it into the utility called cut. And then that utility is the -d is telling it a delimiter. So it could be a comma, it could be an @ sign, whatever that delimiter is from whatever output you're sending to cut. In this particular situation, it's a space. And so what cut does is it uses that delimiter like a CSV, and that's how it looks at it. In each field, 1, 2, 3 to n-1, right? So I'm saying the delimiter is a space, and I want the fourth field. The fourth field is the IP address. And then the double arrow, the double alligator, thank you. I was thinking alligator mouth, but you're not children. That the reason it's pointing, have you guys ever seen this before? The double. Yeah, but it's normally faced that way, right? Not this way.
CN is this way.
Okay, so when you're doing stuff in Linux, it's not chevrons, but it's God, the name's slipping my mind. Huh?
Arrow brackets.
Yeah, whatever. Greater than, less than sign. That's what I'm going to call them. That's what they are. All right. So typically when you're piping stuff, you're writing to a file. So you'll have the alligator mouth or chevrons, whatever, pointing to the right. And that means take all of this input and throw it into this file when it's pointed to the right. When it's coming to the left, you're saying take this file and throw it into here. Oh my God, I just screwed you guys. Reverse everything I just said. What the hell am I thinking? I am so sorry. No. This is the problem with the late night stuff too, by the way. Oh God, how can I help undo this? What I'm doing is I'm piping the stuff into the IPs file. Reverse my chevrons. My God, I am so sorry, everybody. See, this is why I don't consider myself an expert. I screw up like this. That's what it's doing. It's
putting those results into a file.
no, it's yes. Yes, it's putting the results into the file. And the other way is taking them out of the file. So you'll
TXT and saving that to the desktop.
yes. So what I'm talking about is if I come here and I do Oh, one funny joke that I hope nobody ever falls for, and I did, is there are a couple commands on Linux, man and touch. So when I first started my first job, somebody had me do that, and someone else had me do this. So, yeah. And so, you know, not that I'm just saying you'll get laughed at. I got laughed at. It's just stupid. It's what happened to me. So I try to warn people. Touch is a utility to create a file. Man is the manual tool. That's all it is. All right. So whenever, another bad thing about me, whenever I do a test on something, I need to create a file. That's what I do. It just gets me and my coworkers a good little laugh. All right, so I'm doing that. Can you guys see it? Everybody can see it, right? Sure. Not that way. Good? All right. So if this is a utility called Vi. I'm opening up Vi and I will do, there we go. All right, so I left Vi, right? Now I will do, while read line, do that. Actually, you know what? Oh, ha. What did I mess up on? Line do record line done. Yeah, that looks right. Whatever. I'll figure out what I screwed up on later. Back to the other thing. So I was just trying to show you the difference, and I screwed that up too. So there's that. So we're back to cut. Cut is piping the stuff into IPs.txt, and I'm saying done. And have you all ever seen the two double ampersands?
Yeah, it's like testing with true or false.
No, it's in Linux. It's what's that? Well, what do you think does?
Just like programming, it's just like an and.
Yeah, and programming is saying like and or by it's doing a conditional statement, right? But here, what it's doing in Linux is it says wait for this process to terminate. Once this process terminates, execute the command to the right of me.
So what does this?
Oh, that's like short circuiting.
Sure, I'll take your word on that one.
Yeah, because that's like there's like something like that in programming where it doesn't do the whatever's on the right of the two and signs until the left is true.
Oh, okay. Yeah, and by true, for this situation, it'll be terminated.
Yeah, so it returns to 0, which means
So
it went, right?
yes,
It returns like 1 or something like that, some truthy value.
it whatever the result is indifferent to the other side, as long as it terminates. If it terminates, then the right side will get actuated. Right now, I'm doing the ping, and okay, sweet. So I got 2 addresses that were up. So what I just did was I ran that huge command, and I piped it into all those things, and now boom, after the 2 ampersands, it says cat ips.txt, and what that did was just pipe out or cat out the contents of that file. So now I need to, so sed is another tool that you want to get comfortable with. Sed is a good way to, it's a good tool to make in place, can extend to backup. It's a great tool. I want to say every Linux has is to let you that they are the root of the doing. You're trying to set important to not bring everything with you. So what SET is doing is the dash I is in place. The the apostrophe, no, not apostrophe. I told you, dude, I am gone. Somebody help me. The print, it's not, it's quotes, the quote. Thank you. The quote. So you quote, then the S is the substitute. You do the slash. After the first slash is the delimiter, or it's what you're substituting. So it's the old text, another slash, new text, and then slash G, I'm done. Good. No, I got my sodas. They can see a thing. All right. So what I'm doing is I'm telling SED to replace, you see in the cat, when I catted out that file, how it has the colon after the IP. Well, that's not a valid IP address because there's no IP out there that has a colon at the very end, right? So I'm lazy. Rather than opening up the text file, I mean, it's fine if I have 2 IPs, but what if this text file had 253 IPs, right? Not something I want to do. SED is quick. I mean, like that. So it doesn't matter the size of the file. I do that. Now I cat it out. The colon's gone. So now I have a list of files that I can actually use to be able to, or I have a list of IPs that I can actually use to be able to read from.
So is SED like rejects? Like,
What's rejects?
or like, I just.
You mean like regex?
Yeah.
No. SED is, oh God, people are going to hang me for my opinion on this one, for what I'm going to say to you. SED is a good search and replace tool.
So
Find and replace.
you just replace the colon
With nothing.
It's like you would do something similar like in regex.
Yeah, and that's what it's doing, except it's not looking for, my experience with SED is not beautiful. So bear with me on that one. When it comes to how complex you can get with what you're replacing, anytime I've used SED, I've known exactly what I'm replacing, where I'm replacing it at. So
Like here you knew that it was a colon. So
yeah, I mean, I've had text files that were like, 5 megs, and I had to go through and replace, say a comma with a new line, or certain phrase in there where it says Steve and it needs to say Fred in every spot. Well, opening up a 5 meg text file it takes up a lot of energy. It takes up a lot of memory from the computer, right? SED is able to just do it all in memory, call it a day. So it takes it as if I remember correctly, a file stream. So it's quick. So we have the IPs on here, right? This, God love me, is what I was trying to do. No. This on that other command line. So this is what we were talking about when I screwed you over with the whole less than greater than facing the wrong direction thing, right? So on this one with the director, the less than greater than symbol going this way, going to the right, don't mock me. For this one going to the right, it means it's reading from this file. So I'm taking every single line that's in ips.txt, and I'm bringing it over to my while loop. And what my while loop is saying, while read this file, substitute each line in this file for the word line. So line is my variable, right? Then I'm saying, after you do that, run netcat-nv-uzw. All those switches, honestly, I can't remember what all of them do. It's like verbose, check, wait like 1 second, and I think that's even UDP, which I don't need. So anyway, no, it's not UDP. I'm sorry. Anyway, so what I'm doing is I'm saying, do this, run this command. So that's no different than me saying, for every line, run the command echo. Everybody knows what echo is? Yeah. So for every line, echo out the IP, right? This is no different. This is saying run a command called netcat. Netcat is another utility. The only problem with this command here is it is not standard issue on Linux distros. I don't believe it is. It's been a while. It's been a few years since I've had to actually do stuff. So, but Netcat's like, I think it's like 30K in size. It's not huge, right? So bringing Netcat over, if you have to, not a big deal. So that's why I chose to use Netcat. And what Netcat is doing, is anybody familiar with Netcat? No. Chat. They don't care. They're watching movies. No, so it's a tool that you can inline to I don't it's a command line you to be able to connect to different servers or just connect on command line and you can run command zone. So like I can see port 22 is open. I can act we'll go with that later. That's so here we go. All right. All that's doing is just saying run netcat and let me know which port is open, or let me know a specific port. Again, stuff that you can do with mmap or mass scan, and you can actually do a whole lot more ports and you can do a whole lot more scanning, but none of those tools are pre-built and come shipped with Linux distributions. With netcat, I have to put in a port. I can, we'll just leave this like this. All right, I can put in the port. So the port that I'm looking for is 80, right? So what I'm doing is what I found through my test now is I found that the IP address 192.168.252 has a web, it's web accessible. So did I tell you guys, please God tell me I didn't. Did I tell you guys netcat is used to determine, like you can determine services are open? Hold on. I didn't, did I say that you can, whatever I said, hopefully it was right. I can't remember what I said. There's netcat and telnet. Telnet, you can telnet into a machine and run certain commands onto it. Netcat is the utility that we just used that you can also use to create verse shells. So we're good there. All right. So I hope so. So curl, you're only on a box, right? You have command line access. You don't have a web browser. Even if you do, command line, getting comfortable with it is crucial. It's critical. So I want to curl this address, right? Now I could create a file that says, okay, anytime I see, there we go. I could create something, a longer command, and this thing could spread out forever saying, if you do this, do this, do this, do this, do this. The idea isn't to try to confuse people. I'm just trying to do it step by step, right? It's interesting. Oh, hold on. I'm not thinking. Well, netcat told me it was open. Now it's closed. Well, here comes our problem. Let's do this. You asked for it, buddy. Sorry, what I'm doing right now is I'm irritated because it told me that port 80 was open and it's not showing it to me, and that bothers me. So this is a map, the very thing I told you guys don't try to use, but honestly, I'm irritated. That's why I'm using it. It could just be how your classroom is set up. Be very verbose, scan all the ports, do a send, scan, and output all file types, XML, greppable, and HTML. Those are what the commands stand for. And so it's scanning 65,535 ports. And we'll do, that was silly of me. That was my file. Yeah, all it was able to tell me is that it was up. I scanned all the ports on it. So I'm going to go ahead and chill out right there because I am already 6 minutes over time and I don't have anything further to show you guys with regards to accessing the web. We kind of went all over the place. So if I can leave you with nothing else, I want to leave you with a couple things. All right. Do you want me to just put this file in Discord? Do you want me to?
Actually, yeah. And that was amazing. Yeah, I really appreciate you. Yeah, we're like 6 minutes over, but yeah, this is great. And like, sorry, like we had like not that many people. Like,
Don't apologize. Don't apologize, dude. What you guys are doing is freaking
Yeah.
amazing. So don't apologize.
Yeah, I mean, yeah. So for those who are in our online Zoom room, yeah, I guess thanks for being there, and I'm sure a lot of the teams are watching in right now. But yeah, I mean, we're just all pretty tired at the end of the day and stuff. And yeah, I mean, thanks again, Josh, for like sharing all these stuff. And if you could, oh yeah, post them in the Discord, that would be great.
This one?
No. So go down to keep going down. Right there, intro to cybersecurity. Yeah, and then you can post something there. Yeah, but all those commands will be on the Discord, and yeah, I guess that just concludes day one of the hackathon. So yeah, thanks y'all for coming, and yeah, we'll see y'all tomorrow, and we'll be sending out a bunch of more announcements. And yeah, thanks again for coming, everyone. We really appreciate it. So
I hope you guys got something out of it. All right. Oh shit, it's still recording. I'm still presenting. Hold on.
Yeah, I'm gonna.
There we go. There's that. I can leave it.
Oh yeah, one more thing. I need to say something else.
Do you want me to leave it?
Yeah, you're good. Yeah, you can leave if you want. All right. Oh yeah, last announcement to anyone if you're listening. If you attended this like terminal workshop, or if you attended the app development one that was right before this, we'll be sending out the codes for those. So yeah, just check the Discord for the raffle codes. But yeah, that's it for today.
Thanks for having me. Yeah.